Ladies and gentlemen, please welcome our Master of Ceremony, Rara Sandi Winanda, Master of Science.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, distinguished guests, esteemed speakers, and participants. Welcome to the opening ceremony of the 7th International Conference on Mathematics and Mathematics Education, organized by the Mathematics Department, Faculty of Mathematics and Natural Sciences, Universitas Negeri Padang. I am Rara Sandi Winanda, and it is a privilege to serve as your Master of Ceremony today. We are truly delighted to have all of you here, both in person and via Zoom, joining us for this important event. This year's conference theme, Enhancing and Connecting Sustainable World and Future Technologies in Research of Mathematics and Mathematics Education, highlights the essential role that mathematics and education can play in addressing global challenges and future technologies. Throughout this event, we will learn from distinguished experts who will share their insights on mathematics and mathematics education. Ladies and gentlemen, to mark the beginning of this ceremony, we are honored to present a traditional dance, a cultural expression symbolizing our warm welcome and hospitality to our esteemed guests. This dance, Tari Pasambahan, will be performed by students from the Mathematics Department, Universitas Negeri Padang. Sairiang balam jobarabah, balam lalu barabah mandi. Sairiang salam nanjo sambah, salam lalu sambah kembali. Please welcome Tari Pasambahan. Thank you for the beautiful and graceful performance. Now, may I kindly ask everyone to stand for the singing of our national anthem, Indonesia Raya. Hadirin dimohon berdiri. Thank you. Please be seated. Ladies and gentlemen, next let us proceed with the recitation of the Holy Quran, which will be recited by Khairul Zaki, accompanied by the Sari Tilawah by Fatia Al-Fadilah.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim. Bismillahirrahmanirrahim. Ya ayyuhalladzina amanu idza qila lakum tafassahu fil majalis إذا قيل لكم تفسحوا في المجالس فافسحوا يفسح الله لكم وإذا قيل انشزوا فانشزوا يرفع الله الذين آمنوا منكم يرفع الله الذين آمنوا منكم والذين أوتوا العلم درجات والله بما تعملون خبير والله بما تعملون خبير صدق الله العظيم.
Aku berlindung kepada Allah dari godaan setan yang terkutuk dengan menyebut nama Allah yang Maha Pengasih lagi Maha Penyayang. Wahai orang-orang yang beriman, apabila dikatakan kepadamu, berilah kelapangan di dalam majelis-majelis, maka lapangkanlah. Niscaya Allah akan memberi kelapangan untukmu. Dan apabila dikatakan, berdirilah kamu, maka berdirilah. Niscaya Allah akan mengangkat derajat orang-orang yang beriman di antaramu, dan orang-orang yang diberi ilmu beberapa derajat. Dan Allah Maha teliti terhadap apa yang kamu kerjakan. Maha benar Allah dengan segala firman-Nya. Assalamualaikum warahmatullahi wabarakatuh. Thank you, Khairuzaki and Fatia Al-Fadilah for the beautiful recitation. Ladies and gentlemen, we are honored by the presence of several distinguished guests among us today. The Honorable Rector of Universitas Negeri Padang, Krismadinata PhD, Vice Rector Universitas Negeri Padang, Dr. Refnaldi M. Lid, Dean of the Faculty of Mathematics and Natural Sciences, Dr. Yukifli MSI, Vice Dean of the Faculty of Mathematics and Natural Sciences, Prof. Yuni Ahda MSI and Dr. Irwan MSI. Head of Mathematics Department, Dr. Suherman MSI, along with the esteemed heads of other departments within the Faculty of Mathematics and Natural Sciences, Universitas Negeri Padang. We deeply appreciate your presence and support in this significant event. Now, without further ado, I would like to invite Dr. Yulianti Harisman, MPD, the chair of the committee, to deliver her welcoming speech. Dr. Yulianti, the floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. Peace be upon you, mercy and blessing of Allah be with you. Good morning and very warm welcome to all of us gathered here today. Distinguished guests, we are honored by the presence of Rektor Universitas Negeri Padang, Krisma Dinata PhD, Vice Rector Universitas Negeri Padang, Dr. Refnaldi Amleit, Dean of Faculty Mathematics Natural Science, Dr. Yulkifli Master Science, Vice Dean of the Faculty of Mathematics and Natural Science, Professor Yuni Ahda Master Science, and Dr. Irwan Master Science, Head of Mathematics Department, Dr. Suherman Master Science, and esteemed Head of Department within the Faculty Mathematics and Natural Science, Universitas Negeri Padang. Committee, keynote speaker, presenter, and all of participants who attend this international conference. We began by expressing our sincere gratitude to Allah Subhanahu wa Ta'ala for His infinite mercy and grace that has all of us together here today for this international title, Enhancing, Connecting Sustainable World and Future Technologies in Research and Mathematics Education. This seminar, proudly organized by Mathematics Department of Universitas Negeri Padang, is timely responses to the challenges of globalization. The ever-increased pace and change has significantly impacted development of information technology, which is in turn has had a profound effect of the advancement of science, particularly in this field, mathematics education, statistics, and computer science. The integrations of technology in classroom has improved the quality in STEM learning. Recognize these crucial connections. We are honored to have four distinguished of keynote speaker in house today. The first one, Professor Masami Isoda, who come from Tsukuba University in Japan. His expertise is mathematics education. The second one is Professor Matthias Ludwig, who come from Goethe University in Germany. His expertise is mathematics education. The third one, Associate Professor Budi Arta Surya, who come from Victoria University in Wellington, New Zealand. His expertise is mathematics. And the last one, Associate Professor Meira Parmadewi, who come from Universitas Negeri Padang. Her expertise is mathematics. Also, we are proud to welcome a total of 115 participants and presenter 43 through offline and 72 online, representing to the various esteemed universities such as Institut Teknologi Bandung, Universitas Jambi, Hiroshima University, Universitas Andalas, Universitas Negeri Balang, Sekolah Tinggi Manajemen Trisakti, and many more that I can't mention one by one. Well, this international seminar will be held for 2 days. Today are opening ceremony and plenary sessions, and tomorrow we will have parallel sessions where scientists and researchers can share their valuable research and findings. On behalf of the organization committee, I extend our deepest gratitude to everyone who has worked tirelessly to make this event success. We as committee also apologize for any shortcoming you might encounter. We wish you all have positive experience at this international seminar. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Peace be upon you, the mercy and blessing to Allah subhanahu wa ta'ala. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Yulianti, for your inspiring and insightful words. Next, we invite Dr. Yulkifli, MSE, Dean of the Faculty of Mathematics and Natural Sciences, to give his welcoming remarks. Dr. Yulkifli, the stage is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirrahmanirrahim. Wassalatu wassalamu ala asrafil anbiya'i wal mursalin wa ala alihi wa ashabihi rusulillahi ajmain. Honorable Rector Tes Negeri Padang, Kris Madanata PhD. Honorable Vice Rector, Academic and Student of Tes Negeri Padang, Dr. D. Emlit. Head of Department in the Faculty of Mathematics and Natural Science, keynote speaker and invited speakers, committee of this conference, and dear participants. Ladies and gentlemen, first of all, I would like to thank Allah Subhanahu wa Ta'ala for blessing us and allowing us to attend this conference in good condition. Salawat and salam are always given to our Prophet Muhammad Sallallahu Alaihi Wasallam, peace be upon him. Ladies and gentlemen, I welcome you to the 7th International Conference on Mathematics and Mathematics Education 2024, hosted by the Mathematics Department of the Faculty of Mathematics and Natural Science, Universitas Negeri Padang. I would like to express my gratitude to all the keynote speakers who have graciously accepted our invitation to their knowledge and experience in variety expertise. I believe that your keynote speak will make a significant contribution to the audience of the conference. To all speakers and participants, I'm greatly honored and pleased to welcome you to this conference. Before we begin this international conference, I would like to express my gratitude to all of you who sincerely committed to this event to make it success. This event would have been impossible without the support of everyone present here. This conference is a special occasion for those who work in mathematics, mathematics education, statistics, computer science, and other related fields. This year's theme is enhancing and connecting sustainable world and future technologies in research of mathematics and mathematics education. And we expect that the conference will enable you to share your research with international research communities and to engage in discussion about issues relating to research and our practice. Hopefully, this conference will contribute to innovation entrance in mathematics education, and also other related fields for global challenges. This conference provides clear evidence that University Negeri Padang has a strong commitment to contribute positively to development of human resources and education in Indonesia, especially the Faculty of Mathematics and Natural Science, which are gone together with excellent and HEMIPA heaven. Finally, we respectfully request that this event be formally opened by Vice Rector Dr. Nadit Universitas Negeri Padang. Thank you and on all. Have a great discussion. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Zulkifli, for your encouraging words. Now we are honored to invite Dr. Refnaldi, SPD MLID, Vice Rector of Universitas Negeri Padang, to deliver his speech and officially open the 7th International Conference on Mathematics and Mathematics Education 2024. Dr. Refnaldi, the floor is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirrabbilalamin. Salatu wassalamu ala asrafil anbiya wal mursalin wa ala alihi wa sahbihi rasulillahi ajma'in. Asyhadu an la ilaha illallah wahdahu la syarikalah wa asyhadu anna Muhammadan abduhu wa rasuluhu la nabiyya ba'da, amma ba'du. A very good morning, ladies and gentlemen. The Honorable Dean of the Faculty of Mathematics and Natural Science, Universitas Negeri Padang, Bapak Associate Professor Dr. Zulkifli, Master of Science, Vice Deans of the Faculties of Mathematics and Natural Sciences, Department Heads, Committee Chair, and all the members of the committee, and especially to all the participants of the International Conference on Mathematics and Mathematics Education. Our special honors is addressed to the keynote speakers of this year conference. The first one is to Professor Budi Artasurya from Victorian University in Wellington, New Zealand. The second one is to Professor Masami Isoda from Tsukuba University, Japan, and to Professor Matthias Ludwig from Goethe University, Germany. Then to the Associate Professor Meira Parmadewi from Universitas Negeri Padang. It is an honor for me to be here in this room to officially open this international conference. And this is the 7th international conference, a very great one, because Department of Mathematics is able to hold the international conference every year, even in the pandemic situations. Then we know that hosting the international conference is not that easy, because we need to consider many things. The first one, we need to consider the times available for our keynote speakers and also the participants that we need to invite from several institutions, nationally and internationally. Then the second one is we need also to consider the themes. the very hot issues or the very hot themes that we need to discuss in each year of the conference. And today, this is a very great one. We also have the new themes in our conference. So two main themes in this conference, that is mathematics, then mathematics teaching. We understand today that with the development of technology, then many people assume that technology can replace teachers. But that's not true. Teachers cannot be replaced with technologies. There are many aspects of things that cannot be replaced by technologies. Teaching with souls is something that cannot be replaced by technology. Because of that, we need to develop models of teaching mathematics which are in line with the development of technology. Then the second one is research on mathematics. We understand that the development of research, especially in the areas of mathematics, is very vast, and we need to be in line with that development. Mathematics is not a mathematics for its own sake, but mathematics is very useful for our society. So applied research on mathematics is very useful right now. How can we use mathematics or the result of the research on mathematics in our society? Not only about the mathematics for its own sakes. The research on mathematics teaching is also developing. Many issues, many topics are developed right now. Then now it depends on all the participants which part of mathematics teaching are going to be delivered or are going to be introduced in this international conference. Finally, I'd like to thank all the committees of this conference who has worked very hard, who has planned this international conference or this 7th international conference very well, and also to the invited speakers who have provided the times to be speakers in this conference, and especially to all the participants, because without having the participants, then we are going to have no conference. No conference without participants. I think this is a very useful one. Then today we have so many participants, whether it is whether they are going to represent offline in this room and whether they are going to be present in online mode. Then lastly, we also thanks to the managements of the Faculty of Mathematics and Natural Sciences who have provided full support for this conference. Then to the invited speakers and parallel speakers, because the ideas that they are delivering will create so many hot discussions, especially in Q&A sessions, and also will enrich our knowledge, our experience in mathematics in general and mathematics education in specific. Finally, with the permissions of Allah Subhanahu wa Ta'ala, and also with the support for all the participants who are present in this room, I'd like to say that this 7th International Conference is officially declared open to public. Thank you. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Thank you for your insightful remarks, Dr. Refnaldi Emlit. Let's give a warm round of applause again for the official opening of this year's conference. To conclude this opening ceremony, we invite Mr. Andi Okto to lead us in the recitation of doa, asking for blessing upon today's gathering.
Assalamualaikum warahmatullahi wabarakatuh. Marilah sejenak kita bersama-sama menundukkan kepala bermunajat kepada Allah agar kegiatan kita hari ini diberkahi dan bisa berjalan dengan lancar. Bagi yang beragama Islam akan saya pimpin, bagi yang non-muslim silakan menyesuaikan. Astaghfirullahaladzim, astaghfirullahaladzim, astaghfirullahaladzim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Hamda syakirin, hamda na'imin, hamda yuafi ni'amahu wa yukafi mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhika wa 'azimi sultanik. Allahumma salli wa sallim ala sayyidina Muhammad wa ala ali sayyidina Muhammad. Ya Allah, ya Rahman, pada hari ini di Gedung Senat Rektorat Universitas Negeri Padang, kami hendak menyelenggarakan International Conference on Mathematics and Mathematics Education dengan memohon ridho dan izin-Mu. Berkahilah semua langkah dan perbuatan kami, dan jadikanlah itu semua nilai ibadah dan nilai ilmu yang bermanfaat bagi kami. Ya Allah, ya Wahid, Engkau yang Maha Satu dan Maha Mempersatukan. Kami mohon perkuatkanlah persatuan di antara kami, janganlah Engkau biarkan ada perpecahan di antara kami. Kami ingin kuat dalam persatuan itu, agar bermanfaat untuk agama dan negara dan bangsa ini. Ya Allah, ya Ghafur, Engkau yang Maha Pengampun atas segala dosa. Ampunilah dosa kami, dosa orang tua kami, dosa para pemimpin kami, dosa para pejuang-Mu, dan dosa para pendahulu kami. Tempatkanlah kami dan mereka semua ini dalam lindungan rahmat dan ampunan-Mu. Ya Allah, ya Mujib, Engkau yang Maha mengabulkan doa. Perkenalkan doa dan permohonan kami. Rabbana hablana min azwajina wa zuriyatina qurrata a'yun waj'alna lil muttaqina imama. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Andi Okto. Before we proceed, we would like to capture this special moment with a group photo. For online participants, kindly turn on your cameras to join us in this photo session. For those present in the seminar room, please come forward to the stage area for the group photo. Kepada para peserta, kita akan berfoto bersama. Silakan maju ke depan untuk kita berfoto di depan ini bersama-sama. Kepada para peserta, silakan mengambil tempat di belakang. Kita akan berfoto bersama di area ini. Awak jam berapa, Wak? Dia 30 ya. Mesti 30 menit ya. Ditunggu aja. Iya, boleh, Pak. Iya, kita kasih tahu dulu. Ladies and gentlemen, this concludes the opening ceremony. We will now take a short break, after which the plenary session will begin. Please remain connected or start maybe for a series through-provoking discussion and presentation by our speakers. Bapak dan Ibu, kita istirahat sejenak sebelum sesi plenary. Kita akan kembali lagi ke sini jam 9.30 untuk memulai sesi plenary. Diharapkan Bapak dan Ibu berada pada area yang cukup dekat biar tidak terlalu lama nanti untuk ke sini. Terima kasih.
Ya, sudah ini. Thank you.
Selamat datang di Universitas Negeri Padang, tempat di mana masa depan cerah Anda dimulai. Kami dengan bangga mempersembahkan program studi baru yang dirancang untuk memenuhi kebutuhan industri modern. Program studi S1 Ilmu Aktuaria.
Ilmu aktuaria adalah disiplin ilmu yang menggabungkan matematika, statistik, dan teori keuangan untuk mengelola resiko di berbagai sektor, terutama asuransi dan keuangan. Peluang karir dalam bidang aktuaria sangat luas dan beragam. Menurut Otoritas Jasa Keuangan, Indonesia membutuhkan lebih dari 1.000 aktuaris bersertifikasi untuk memenuhi permintaan industri.
Program studi ilmu aktuaria di FMIPA UNP menawarkan kurikulum yang komprehensif dan dirancang untuk mengasah keterampilan analitis dan pemecahan masalah. Anda akan belajar dari dosen berpengalaman dan ahli di bidangnya. Fasilitas kami lengkap dan modern, yang mendukung proses belajar mengajar yang efektif. Kurikulum kami juga mencakup 3 peminatan utama, yang memungkinkan mahasiswa untuk menyesuaikan pendidikan mereka sesuai dengan minat dan tujuan karir mereka. Peminatan tersebut adalah: 1. Pemodelan aktuaria. Peminatan ini fokus pada pengembangan dan penggunaan modal matematis untuk menganalisis dan mengelola risiko dalam asuransi, keuangan, dan bidang terkait lainnya. Mahasiswa akan mempelajari teknik-teknik pemodelan lanjutan dan aplikasi praktisnya. 2. Sains data aktuaria. Dalam peminatan ini, mahasiswa akan mempelajari cara-cara mengolah dan menganalisis data besar untuk mengidentifikasi pola dan tren yang relevan dalam aktuaria. Fokusnya adalah pada penggunaan teknik sains data untuk mendukung pengambilan keputusan yang lebih baik.
Ketiga, bisnis dan keuangan. Peminatan ini menggabungkan ilmu aktuaria dengan pengetahuan bisnis dan keuangan. Mahasiswa akan mempelajari manajemen keuangan, penilaian aset dan strategi bisnis untuk pengoptimalan keuntungan sambil mengelola resiko. Jika Anda menyukai matematika dan juga tertarik pada ekonomi, ilmu aktuaria adalah pilihan yang sempurna. Program studi ini menggabungkan keahlian dalam matematika dan statistik dengan menerapkan langsung dalam dunia keuangan dan ekonomi. Mahasiswa juga memiliki akses ke laboratorium komputer canggih, perpustakaan dengan koleksi buku yang lengkap, dan ruangan diskusi untuk mendukung kegiatan belajar.
Kami di FMIPA UNP berkomitmen untuk mencetak lulusan yang siap bersaing di dunia kerja global. Program ini juga memberikan jembatan kesempatan bagi mahasiswa untuk mendapatkan sertifikasi profesional yang diakui secara nasional dan internasional, membuka peluang kerja yang lebih luas. Lulusan ilmu aktuaria memiliki banyak pilihan karir, seperti aktuaris, analis risiko, underwriter asuransi, analis keuangan, konsultan aktuaria, manajer klaim asuransi, penasihat investasi, pengelola dana pensiun, dan aktuaris pemerintah.
Jangan lewatkan kesempatan ini untuk menjadi bagian dari program studi yang menjanjikan masa depan cerah. Pendaftaran untuk program studi S1 Ilmu Aktuaria dibuka dari 19 April hingga 10 Juli 2024. Untuk informasi lebih lanjut dan pendaftaran, kunjungi halaman web spmb.unp.ac.id/mandiri. Segera bergabung dengan komunitas kami di FMIPA UNP dan mulailah perjalanan Anda menuju karir yang gemilang.
Kita mulai lagi. Oke, Din. Welcome back, ladies and gentlemen, to the plenary session of the 7th International Conference on Mathematics and Mathematics Education 2024. We are privileged to host a series of distinguished speakers who will share their expertise on range of topics in mathematics and mathematics education. Our first plenary speaker is Insinyur Budi Artasurya, MSc, PhD, presenting online. The session will be moderated by Ms. Dina Agustina, SPD, MSc. Please welcome Dr. Budi Artasurya and Ms. Dina Agustina.
Halo, saya dengar. It's a bit echo.
Udah mati, Pak. Bismillahirrahmanirrahim. Good morning, distinguished participants, speakers, and guests. Welcome to the 7th International Conference on Mathematics and Mathematics Education, held on October 26 and 27, 2024. Udah.
Halo, halo. Can you hear me?
The title is Optimal Stopping Problem Driven by Levy Processes and Passing Participle. And the next is Backward Stochastic Differential Equation and their application to hedging and portfolio optimization problem under transaction cost. And the last is estimation of stochastic volatility in the whole wide models using nonlinear filtering. About his scholarship, It's so many scholarship that he got and research contribution for the material about complex stochastic system modeling, Markov chains, and until the applied probability and its computational aspect. And also his research collaboration, we can see it's so many, and supervise our former students. And after that, research grant that he got, and also editorial activities and external research consultancies and select accepted publication, and also submitted our working papers. So many achievements that he got, and today, Associate Professor Budi Artasurya will present the topic of estimation in general mixture of Markov jump process. This presentation will focus on advanced statistical method for estimating state in complex system. We look forward to the valuable insight he will share with us today. The presentation will last approximately 45 minutes, followed by a 15-minute Q&A session. During the Q&A, please feel free to submit your question in the chat box if you are joining us online, and or raise your hand if you are attending in person. Now, without a further ado, let's welcome Associate Professor Budi Artasurya. Time is yours.
Okay, can everyone hear me? Yes. Can everyone hear me? Okay, so first of all, I would like to thank the organizer to give me the opportunities to share my my work in these occasions, and for that invitations, I would like to say thank you for the invitations, and also before I start my talk, I would like to say something to acknowledge distinguished guests who are Director Magnificus of Universitas Negeri Padang, Pak Krisma Dinata PhD, Vice Rector, Alhamdulillah, Vice Rector Universitas Negeri Padang, Dr. Refnaldi SPD, MLit, and then Dean of Faculty of Mathematics and Natural Sciences, Dr. Yul Kifli, MSc, Vice Deans of FMIPA, Professor Yuni Ahda, MSc, Dr. Irawan, MSc, and head of the Mathematics Department, Dr. Suherman, MSc, and also all the corresponding staff at the Math Department of Universitas Negeri Padang. So thank you all for this opportunity. Now, so let me start with my presentations. So today I'm going to talk about estimation in a general mixture of Markov chain processes, and this is a joint work with Alina Friedman from New York University Stern School of Business, who I visited in September 2019, and this is also I'm going to visit her again in inshallah April next year for a giving seminar, invited seminar at NYU, and also to continue this joint work. Now, so these are the outline of my talk. So I will start my presentation by discussing the maximum likely estimation from incomplete data, and then EM algorithm, and then also parameter estimation of the mixture of Markov processes, and EM algorithm for the estimations, and also I will proceed some numerical examples. So by the way, this is my current affiliations, Victoria University of Wellington. I am one of two key lecturers in actuarial science and statistics at the university. So for those who are interested in doing PhD in actuarial science, please feel free to get in touch with me. Okay, we can talk about this later on. So let me talk. So what is? Let me start my talk. So what is data? So in general, what we are dealing with estimation of parameters from data distribution of the parameter distribution of our data. So in this case here, our data is y, which is partially observations of the factor x. So factor x is a complete data, whereas what we observe is only a factor y. It is only a partial of it. As you can see here, the dimension of factor y is less than dimension of factor x, because we only observe partially. Now, for formality of discussions, both random factors x and y are defined on the same probability space. So the triplet omega, the filtrations, this is sigma algebra generated by the sample space omega, and the probability measure on the filtration f. Okay, so now denote. So we denote by x. This is most called x and s as the and y and t. So these corresponding measurable state spaces of x and y, on which the two random variables factor x and y are defined. And the t. So the t is the t. So the t, let me check. I don't know. I'm not really sure. Can you see? Hello? Oh yeah. Yes. Is it better now? Okay. So let me go back to the my screen again. Now, so yes. Now, so this is the now the PDF. So as we know, the little x is and the little y are the realized value of the random factor x and y. And then, as we know, the random variables are uniquely characterized by the PDF or the distributions. And then, so we define here the FCX theta is the PDF of x under complete informations. Yeah. So theta is the, as I said, Leon, is the parameter that characterize the distribution of your complete information x, and whereas f superscript o of y given theta is the PDF of the observations y. Yes, under the same parameter theta. So now we want to the problem here is to estimate theta, which is the parameter of the complete information x from the partial observations. Okay, so this is the main topic of my presentation today. Now, for the for each of the presentations, we define here D is the dimension of your parameter theta. So it is basically, it says the number of parameter sitting in theta. Okay, now the point here, so we can also relate the incomplete information PDF F superscript. We can relate the two PDF by the equation 1. So it is basically you integrate the PDF under the complete information PDF over the value x of y over the set matcal x of y. So it's defined on the top of equation one. So this is very this is fundamental equations that relates the two PDF. So one the PDF of the incomplete information in terms of the PDF of the complete informations. Now, so I use this a lot. This is this identity in my other work, like in filtering and so on. So now, so as you can see here, now if you want to, so if we check the log, right? If we want to derive the score functions, so the score function is basically the derivative with respect to theta of the log PDF. So this is basically equation one determines the likely functions of your observations y. Now, if you check the log, as you can see here, it doesn't give you a nice formula. You know, if you want to differentiate, if you want to calculate if you want to derive the score functions of theta, as you can see at the bottom equations. Now, this is very difficult, you know, to find the maximum likelihood estimator of theta hat by solving by finding theta from these Euler equations at the bottom of this slide. Yeah, as you can see, theta is sitting in the numerator and in the denominator in a highly nonlinear fashion, and then this is it's difficult to single out the MLE theta hat from these equations. Now, as you can see here, the complexity, the difficulties in finding explicit MLE theta hat from these equations is becomes more is higher. I mean, the complexity becomes more become more challenging in this because we have the sum here. So this is basically the sum of the division of two highly nonlinear functions, and then it's inside integral. So it is very complicated to find theta hat in there. Now, so to overcome this problem, so keep in mind from this equation here. This is if we want to solve this problem, you will find you cannot find it explicitly. So what we want to do is to derive theta hat iteratively, yeah, recursively. So using the so-called EM algorithm. Now the EM algorithm is was first proposed by Dempster in 1977. This is published in the journal Royal Society Statistical Society Series B, top journal, one of the top journal in statistics. So they propose this equation. So so given for a given observation y, yeah. So the initial initial value of your estimate of your MLE theta at the iteration step L. So the update of your MLE is given by maximizing these conditional expectations. Yeah. So this is called the EM algorithm. Now, what we using this algorithm, we want to solve the problem considered here for the mixture of Markov jump processes. So what is a mixture of Markov jump processes? Now, before I discuss about the mixture of Markov jump processes, so let me discuss about the Markov process. So Markov process is a finite state right continuous Markov process. Taking values in a finite state. So this process has been used to model a sequence of events, and it has been used in many places in actuarial science, finance, economics, biostatistics, epidemiology, and so on. Yeah. So in biostatistics, the Markov process is used to model the changes of health conditions of patients. So this is it's very interesting. Now the only the peculiarity of the Markov process is that it is specified when you specify what. So let me. Okay, is it now? Can you see me now? My slide. What is my slide? I need to. So it's a bit difficult, to. So I prefer to have to present my talk offline, in person. So because of this, I'm not really used to this. Now, so the yeah, where was I? Yeah, so Markov process. The problem with so Markov process is uniquely characterized by the intensity matrix Q. Now, the problem with this Markov process is that it has only it assumes that the subjects of under study are homogeneous, meaning that let's say, for instance, in the application of biostatistics, if we want to model the health changes of patients, you assume that everyone has the same, every subject has the same recovery rate, right? So has the same recovery rate, and also the rates of changing of a health status from time to time. And this assumption is a bit rigid in the sense that it assumes that everyone shares the same, has the same are homogeneous, so to say. Everyone has the same rate of recovery and so on, which is not practical. So what I propose with my colleague from Professor Halina Friedman, was to consider a mixture of a Markov process. So by doing so, we consider that the subjects come from a cluster. So you allow them to come from different subpopulations, cluster. So in each cluster, the process has its own intensity matrix. So this is very general. And the question here, how you define how many a mixture, how many subpopulation are there in the population. So this it can be figured out using AIK information criteria. So this is it's very interesting subject, and this is a generalization of Friedman Illy wrote in 1985. So yeah, so here, so X is defined as the mixture of a Markov process. So in this case here, we assume there is m number of clusters, subpopulations, and then x1. So in each cluster, the process moves with respect to its own Markov process x1 up to xn. Yeah. What is the p? responsible for the proportions. So this is to say what is the proportions of the cluster M in the population. Yeah. So you can conveniently represent the X in terms of the sum like this in equation 3. Yeah. So here, all right. So what we consider here, question 3 is a mixture of stochastic processes, and then this is slightly different from the mixture of distributions. In statistics, there has been many applications and literature that discuss a mixture of distributions. Whereas here, what we consider is the mixture of process. So this is a mixture of process does not necessarily lead to a mixture of the underlying law of the processes, whereas the mixture of the law or the mixture of distributions only corresponds to a special mixture of process. So yeah, so this is question 3 is a more general than the mixture of distribution of the underlying Markov processes. Yeah, so this is the novelty of our work. Yeah. Now, so this is how you describe the transition diagram for a mixture. So in this case here, we have n number of transition states, G1 up to Gn. Now, between the states, between these transition states, the process changes state from time to time. So keep in mind, our time here is continuous. Now, when you observe a process in state Jk, for instance, now we cannot really tell from which mixture does the observed process come from, because keep in mind, in every state there is m number of mixture. There is possibly m number of mixture, and then we do not know, we cannot really tell from which group or cluster the observed process come from. So this is the mixture is like hidden variable. This is latent. You cannot really tell who they are, when you observe them. So and then the process change states through times before exit to observing state. Now, observing state here, this is also an interesting state. So you can think of observing state like the end of the process, like like the instead of the patients. So this is the state corresponds to death or die or exit by the event of interest, let's say by heart attack. This is for the patient, default for corporate bond, and also what else? So many things, exit. So this exit could be subject to censoring. Yeah, so this is it's a lot of things you can model here. Okay, so our parameter theta here of the mixture is specified by P. So this is initial distribution of selecting the initial state of the process, and then Tm and Sm. Tm is the transition, the test generator, for each Markov process in the mixture M. In the mixture M. In the cluster M. And whereas this Sm, this is diagonal matrix, which gives the proportions of the process in each state. Okay, so as you can see here from this transition diagram, so SJKM so tells you the probability of finding the probability of identifying the observed process from coming from the group M. Okay, so we need to estimate this parameter from the realization of the states. Okay, so the process. Now, as I said, this Markov process has been used has been, has found, has enjoyed many applications in finance. This is for modeling corporate bond. Yeah, in actuarial science, and then option pricing, queuing theory, liability theory, survival analysis, marketing, and so on. There are lots of things you can use macro process. Now, this is the intensity matrix of the underlying macro process. Yeah, as you can see, this is TM, DM. So DM is the exit rate. Yeah, and then because each row of the intensity matrix sums to 0, so the each matrix TM and DM must satisfy the sum. Each row sums to 0, and then and also the sum of SIM. So this diagonal matrix here is also it sums to identity matrix. Okay, so so the mixture was first proposed by Blumen et al. This is not 1995. This is 1955. Sorry, there is a typo there. So this is called Mover-Steyer model. So it's a mixture of discrete time Markov chains. And this special mixture is used to model jobs mobility dynamics. How what is the tendency that someone to change the job. Okay. So this is to model the good one tends to move around, whereas the bad one tends to stay within the current job. So this is how they model the mixture. This is special mixture, and then Friedman, my co-author. So in 2005. Actually, sorry, this is not 2005. This is 1985. There's also a typo there. So Friedman consider extending generalizing the mover-Steyer model into a continuous time. Okay, so and then apply in the finance with her colleague Till Schurman from the Reserve Bank of New York. And then they publish the result for modeling the credit rating dynamics. Yeah. So, but this is something. This is mixture is special kind of mixture, and then I proposed to Halina that we could we could generalize the mixture. There was something hidden in the paper, and then I came up with a proposal, and then we published it recently in the Canadian Journal of Statistics. Okay, so now, so let me give you an example. So this is what we the statistics for the observation for the estimations. So PM is this Bernoulli random variable having value 1 whenever the observed process comes from the cluster M. Okay, so BI is this Bernoulli random variable having value 1 whenever the observed process start in the state I at time 0. So Nij is the number of times X makes N I to J transition. Keep in mind the process change states 2 times. So Nij counts the number of I to J transitions. So Ni, so this is the number of how many times the process move out of state I. So this is Ni. So this is basically the sum of Nij for all j is not equal to I, and the Zi. This is the length of times X occupies state I. So you count the length of times how many time how long the process stays within each state I. Okay. Now, so this is the likelihood functions. So the likelihood the function looks like this. Now you can simplify the one below. And then you need to take into account the right sensoring, because right sensoring meaning that your observation, at the end of your observations, you do not really see the event. Okay, so under right sensoring, so we need to take into account the the number of we need to adjust the statistic, the number of transition Nij, and also the surgeon time, the last time the process occupies the state. Yeah, so you need to adjust it because the last occupation times might be right sensor. So you need to take into account that as well. Now, as you can see, the likelihood changed slightly, but it remains the same. You know, actually, the likelihood function stays the same, but the formula stays the same, but the statistic Nij and Zi change. You know, so this is the log likelihood. Okay, and then this is subject to the constraint. Here, the initial distributions sums to 1, and also this is the proportion in each state. Yeah, as you can see, for a fixed I, state I, so the sum of the so SIM gives the probability of finding the observed of the process, the observed process come from the group M. Yeah, so and then it sums to 1. Yeah, so for each I, so you need to take into account this constraint in the likelihood. Now this is the MLE. Yeah, if you have all the complete information. Yeah, so this one here, equation 7, is the likelihood functions of the when you observe the process completely. Yeah, when you have complete information, so meaning that you observe the number of transitions, Nij, Zi, so the number or the length of time the process stays within each state for each K-theory realization of the process, and you also know from which group the observed process come from. So this is complete information log likelihood. Now this is the central to the EM algorithm. Now under complete information, so this is the MLE. Yeah, it is a bit complicated where so it is given here, but this is under complete informations. Now for the under incomplete informations, this is because we do not know the random variable P here. So we need to estimate it using the formula I explained to you before. Now, so by doing that, so now, yeah, so this is the observed visual information matrix. So it required for estimating the standard error. You know, so for the goodness of fit of your estimate, so you need to find the the observed information matrix for each for the estimated parameter. So this is how they look like. This is a bit complicated than the standard Markov process. The standard Markov process, the MLE does not have this formula. This is a more general formula for the mixture of Markov processes. Now, so this is the EM algorithm. So step 1, it start with selecting the initial value of each parameter, and then you update the your initial values using the E step. This is called, you know, so this is you derive it from the conditional expectations I described before. Now, so this is also the E step because you need to calculate the conditional expectation here, which is given explicitly as the following. As you can see, it is quite demanding when if you think of implementing this in practice. Programming, in terms of put this into practice, the algorithm is quite demanding work. Yeah, there's lots of work to do these things. Now, so this is the M step. Sorry, the update. the E step is the step where you need to simplify the conditional expectations. Now this is the update, the M step, where you need to maximize the conditional expectations, and you stop the algorithm whenever this convergent criterion is achieved. Yeah. So some numerical examples here. So this is here we consider three mixture. Yeah. So as you can see here, a mixture of three microprocessors with a different intensity matrix. As you can see, is given here. So these are known. Keep in mind this is for simulations to test the accuracy of our algorithm, whether the theory is correct or not. Yeah. So this is for the matrix SEM. As you can see here, so these are lots of parameter for the estimation. Now, so this is the summary. Yeah, so I compare here the bias and the root mean square error. Now, so as you can see here, so this is K is the number of samples. Now, as you can see here, if you increase the number of samples, the bias decrease. Now, in absolute value, if you check the absolute value, yeah, so for the bias here in terms of 10 to the power minus 2. So this is very small. As you can see, it is decreasing. Yeah, for K is equal 750, 1,500, and 3,000. As you can see here, the bias decrease. Yeah, for each parameter. As you can see here, we have 18 parameters, and this is the true value. As you can see, the bias decrease, and also the root mean square error also decrease if you increase the sample size, and they do so decrease uniformly. You can see in each row, if you check in each row, they decrease. Yeah. So yeah, we need to test whether or not your algorithm is consistent. Your theory is consistent. Your algorithm produce consistent result. Yeah, to see whether or not your estimators are correct. Now, so yeah, so from here, what we can see that your algorithm is convergent. Convergent. So this is what we can summarize from this table. Now, this is the estimator, the MLE. So this is the true value, P1, 1, P1, 2, P2, 1. So this is the probability of finding the process in the step 1 coming from Markov chains 1, and then P1, 2 from the second Markov chains in the step 1, and so on and so forth. Yeah, and these are the observed value. So the true value 0.5, 50%, and there's 30%, and there's 20% from the third groups. So because I removed the third probability because otherwise you have your matrix, your information matrix will not be full rank, so it will not be invertible. So we need to. So these are the independent parameter. Yes. So as you can see here, so let me finish this. So as you can see, the third column, the estimator, yeah, is very close to the true values is 0.5 to 0.4998, and then and so on and so forth. They are very close. Yeah. So meaning that my program worked well. Okay. As you can see, it converts to the true value. Yeah, if you look at this one by one, they are very close to the true value. So, okay. And also the root mean square error. Now the root mean square error, so here the RMSE, this is from your simulations. So because for simulation, the true value, so then you can calculate the root mean square error, the square difference, the sum of square difference between the true value and the estimator. Yeah, so this is the RMSE. Now, so in practice, you don't have it. So you need to use the inverse of the observation information matrix. Now this one here, the last column, now as you can see, my estimator for the root mean square error is very close to the true value. Yeah, as you can see, even the same, yeah, it's very close. Yeah, as you can see it very clearly. So this is very important when you want to apply it, because the RMSE is not you cannot observe it. So this is here. So at the end, and this is this is the goodness of fit. Now I use the m is equal to 2, the actual the actual the actual number of mixture is 2, and then from your using AIC, you select the one with the lowest AIC, and then you can see here your fitted model confirms that the observation comes from two regime. So the null hypothesis is accepted, and this is this case m is equal to 3. And then you see the AC has the lowest value for the 3 regime. So the null hypothesis is accepted. So yeah, so the algorithm is correct. Our theory is correct. So therefore, I think that you can apply the mixture to model, for applying for statistical analysis of heterogeneous subjects as opposed to homogeneous subjects if you use the Markov process. So the mixture of Markov processes gives you the flexibilities in modeling, in capturing the number of homogeneous subjects in the heterogeneity. Yeah. So I stop here. So thank you for your attentions. If you have questions, please feel free. Let me know. Okay, thank you, everyone.
Okay, thank you, Mr. Budi Artasurya, for your insightful presentation. In my
You're
conclusion
welcome.
about your presentation, we know that the estimation in a general mixture of Markov jump processes provide a robust framework for analysis complex dataset, which
Yes,
underlying
that's right.
this approach enhance our ability to extract meaningful insight and make informed decision based on observed data. And
Yep.
now we will open the floor for questions. Please submit your question in the chat or raise your hand, and we will address them one by one. Okay, any question for participants?
Okay, feel free to ask me if you want, any one of you, kalau ada dosen muda yang mau S3, if any one of you wanting to do a PhD in actuarial science or statistics, with me, it's also fine. So, but my expertise is really in probability theory and stochastic process. So with possible applications in actuarial science, finance, financial mathematics, filtering theory, engineering, optimal portfolio, and so on. Okay, so ya, tanya apa aja, jangan malu-malu. Ini ya, saya dulu tahu. So this is the place where I won my juara lomba matematika tahun 1992. Ya, oke. Kalau ada yang tanya silakan. If anyone's wanting to ask me, yeah, please feel free. Tanya apa aja.
Yeah.
In Indonesia, in English is okay. In bahasa okay. In Padang pun is okay. because I'm from Padang also.
There is a question from
Okay, Mr. Budi.
Yes.
One question for you. But before that, my name is Adi from Trisakti School of Insurance. I think I never hear about the Markov jump because in the last previous study I just learned about Markov chain process, and
Yeah, it's good time.
I want to know about the difference between Markov chain process and Markov jump process, especially to apply it in actuarial science. Maybe it's new for me, but and I think that you can briefly short about Markov jump process in actuarial science. Thank you, Mr. Budi.
Okay. Yeah. Shall I answer directly or we collect the question first?
maybe any question, or you can answer directly, Mr.
Okay.
Budi.
Okay. Markov chain process is also called Markov chain. It's also Markov chains, but the different thing is this is at the time is continuous, whereas Markov chains is yeah. So Markov chain process is a reserve. You know, the name is reserved for to separate, to distinguish between the continuous time Markov chains and the discrete time Markov chains. So for the continuous time Markov chains, it is normally called the Markov jump process. Whereas for discrete times, you use the only refer to Markov chains. Now, where you can use the Markov chains in actual science. Now you can use it to model, let's say, for modeling mortality rate. You know, so the mortality rate is defined as the ratio between the intensity, the intensity, the PDF, and then survival probability of the lifetimes of of the policyholder. Okay. Now, now the Markov chains, the lifetime of Markov chains. If you use a Markov chains, the distribution of lifetimes of Markov chains has dense distributions. You know, so the lifetimes distributions of the Markov chains. So this is remember my my presentations. If you look at this transition diagram, so you know the Markov chains exit to the observing state. Now the lifetimes here corresponds to the amount of times until the process exit to observing state. So you can model, you know, like say for instance, the transition from being healthy to getting sick and getting healthy again, get a recovery, or from being sick to getting worse. You know, so the health conditions is deteriorated. You know, it's getting worse and worse. You know, like from cancer state 1 to state 2 and so on and so forth before the patient dies. Yeah, so dies here. So death is represented by the observing state. Now, the amount of times required by the process to move from initial state, let's say from the being healthy or from getting sick to die. So it is a random time. Yeah. So this is called the lifetime distribution or the time to event. Now, so the distribution of time to event, sorry, the distribution of exit time of the Markov chains is dense. You know, dense. Dense is you know, you can approximate any distributions by phase type distribution. So the phase type distribution is the lifetimes of a Markov chains. It's a dense. Now you can dense meaning that you can approximate any distributions. So give me a distribution, give me any distribution. So either the distribution has multi-knot, you know, multi-knot. it has two knots, complete skew, skewed or multi-nodal modal, for instance, you have your multi knots. You can if you I can approximate the distribution with the phase type. So I have a paper on this. If you look at my website, what was it, 2 years ago? I published a paper in a journal of multivariate analysis. So I have a new distributions that characterize the joint lifetime distributions of a mixture of Markov jump process. It is more general than phase type distribution. Now, so again, now because of the uniqueness, the dense property of the phase type distribution, the lifetime distribution of Markov chains, it gives you more flexibilities when it comes to fitting the mortality rate. Okay, and that is flexibility. You can apply it in the actuarial science and so on. And the good things about the phase type distribution is that beside its availability in explicit form, it is also it is tractable. It has the underlying Markov processes, and this is very interesting. I have some work on this. If anyone wants to work with me on this, you are welcome to come to Wellington to do your PhD. But the thing is, you can apply like LPDP, to do to work on this. But the thing is, you need to take a course from me. Anyway, we can talk about this later. Did I answer your questions?
So I can shortly
Mortality.
conclude it's just for the okay, Mr. Udi. So I just have a comfort about Markov jump process is just about the continuous distribution, right? And
Yes.
between Markov jump process, and it also
Yes.
can apply in several cases in actuarial science in life insurance, right? And
Yes.
they also
Yeah, that's right.
give to us. Okay, maybe what the others unique thing about Markov jump rather than a Markov chain? Because I hear about Markov jump. Thank you, Mr. Maybe the last question. Thank you.
Yeah. Okay. So as I said, so for the Markov chains, the time is discrete. So it is not very practical in the sense that because in reality, events like someone get hit by the car, getting sick or die or by any particular events, could be by heart attack or kidney failure or HIV and so on and so forth. So these events occur at any time, continuously. Whereas for the discrete time Markov chains, it only occurs at discrete times, either today, tomorrow, or the day after tomorrow, and so on. This is under countable many of times. It is not continuously. So, and also the distribution is discrete, not continuous. It's more difficult if you apply the there's also discrete time Markov chains, phase type distribution for discrete time Markov chains, but it's it's just complicated. It's more complicated to deal with because working in continuous time, you can do integral. You can do integral and so on for integrations. I just wanted to give you an example. Whereas for this discrete times, you cannot apply calculus. It's quite limited. The model. So yeah. Are you satisfied?
Thank you, Mr. Budi.
Okay, you're welcome.
Okay. Any question from the participants or distinguished participant or guest? You can raise your hand or chat in the box. I think there is no question. Thank you to everyone who participate in this discussion, and a special thanks you again to Associate Professor Budi Artasurya for his time and knowledge. This conclusion, we hope you find out invaluable, and we invite you to enjoy the rest of this conference. Thank you and have a wonderful day. And I will
Thank you.
again to MC.
Thank you for the engaging presentation, Dr. Budi, and thank you to our moderator, Ms. Dina, for facilitating the insightful session. Ladies and gentlemen, we would like to take a moment to recognize the contribution of our distinguished speaker with a certificate of appreciation. Although the certificate will be sent electronically, we would like to formally honor Dr. Budi Artasurya for his insightful presentation and dedication to advancing research in statistics.
Thank you.
We invite Mr. Budi Artasurya to join again and turn on the camera.
Yeah. Can I, is it okay now?
We still cannot. Okay.
Can you see me now?
Not yet.
Yeah.
No? How about
Mr.
this?
Wait a minute, Mr. Budi.
Yeah, it's okay. I'm still here, and my camera is on.
Okay.
Yeah, I can see the certificate. So I thank you for that. I appreciate your, again, as I said, the invitations and then also the certificate. It's a pleasure to give a talk here.
Okay, thank you again, Dr. Budi Artasurya. Let's give him a round of applause. His valuable contribution.
Terima kasih.
Terima kasih, Bapak Budi Artasurya.
Sama-sama.
For our second plenary session, we are honored to welcome Professor Masami Isoda, who will also be joining us online. The session will be moderated by Mr. Ronald Ifandi, SPD, MSc. Please welcome Prof. Masami Isoda and Mr. Ronald Ifandi, SPD, MSc.
Halo tes. Okay. Thank you Bu Rara. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning everyone. Good morning ladies and gentlemen. Welcome to the second session of the keynote speakers segment in this International Conference on Mathematics and Mathematics Education 2024. My name is Ronald Rifandi and I will be the moderator for this session. And I would like to extend our greeting to our keynote speaker, Professor Masami Isoda, who already joined us this morning, today. Good afternoon, Professor Masami Isoda.
Good afternoon. Thank you very much for your invitation.
Okay. Could you hear my voice clearly, Professor?
Yes.
Thank you. So, let me introduce our keynote speaker. Professor Masami Isoda is currently the director of the Center for Research on International Cooperation in Educational Development and a professor in the Faculty of Human Science at the University of Tsukuba, Japan. He earned his master's degree from the University of Tsukuba and completed his PhD in education at Waseda University, Japan. Additionally, Professor Isoda holds an honorary PhD in mathematics education from Khon Kaen University, Thailand, and is an honorary professor both at Pontificia Universidad Católica de Valparaíso in Chile and also in Universidad San Ignacio de Loyola in Peru. So, all right. And according to the number of citations in Google Scholars, Professor Masami Isoda is the top in mathematics education in Japan, and he also ranked as a 13th worldwide in international cooperation. So, big applause for Professor Masami Isoda. And today, Professor Isoda will deliver a 30 minutes presentation on the topic of computational thinking and mathematical thinking in mathematics education on the era of generative AI. And it will be followed by a 30 minutes question and answer. So we will have a discussion after his 30-minute presentation. And now, without further ado, I would like to invite Professor Masami Isoda to deliver his keynote speaker. And the virtual floor is yours, Professor. Please.
Well, thank you very much. And I just want to confirm one thing. In my received invitation letter, it is written 60 minutes of my talk.
Oh, yeah. It's include. It's okay.
Yeah, and 30-minute discussion.
Yes, yes. You can use that time allocation for your speech.
Okay. Yeah, if necessary, I will resume, but I prepared some working activity.
Ah.
Is it possible?
So, in total, 1 hour in total, Professor.
In total 1 hour. Okay, thank you very much. Okay. Could you allow me to share the screen? Could you please allow me the screen to share?
Yes, you can share the screen, Professor.
In my side, not yet.
Wait a minute, I will contact the technician first. Could you please try to share your screen, Professor?
Yes, yes, now. Okay. Okay, can you see my slide?
Yes, it's clearly, Prof.
Okay, thank you very much. First of all, I would like to deeply acknowledge ICM Mathematics and Mathematics Education committees for providing me the opportunity, and it is an honor. And I also would like to acknowledge all of the friends and collaborators and colleagues in Indonesia, because I have been working with the textbook development project for Indonesia and some research project with female centers such as female QUITEP in mathematics, and also APEC project members. Thank you very much. And I would like to discuss, inform with the conclusion. My conclusion is specific mathematical and computational thinking can be developed through the repetition of the appropriate task sequence. Repetition of task by the appropriate task sequence. Okay? and which use student already learned and prepare necessary representation in future learning. How do you say Bahasa Indonesia? Use what student already learned and prepare necessary representation in future learning. Did you translate it in Bahasa?
Okay.
Okay. And which promote reflection and appreciation. How do you say reflection? And how do you say appreciation in Bahasa Indonesia?
Reflection is refleksi.
Thank you. I just posing the question to the audience. Okay.
Audience.
Yeah, thank you very much. And this is the this is the differences. Most of them are free. And in the case of the newest edition of the textbook, must in English you may need to buy, but however, Bahasa Indonesia edition existed. It is honor for me. Thank you very much for the collaborations. And okay. Did you read? Did you read? If you read, it is in Bahasa because your textbook, from your textbook, okay? Solve those cases, 5 cases about those 2 questions. Please write down it on the notebook. Later, I'll come again on this example. Did you wrote on your notebook those student posed question in vertical form, in column method, okay? If you done, okay, did you solve it? You may solve it in your mind already, right? And my question is, by using this task, can you imagine what I will discuss later? What shall we discuss by using this task? Okay, this is only one task, but I wanna discuss about task sequence. Okay, okay, this is a kind of the assignment, okay, for us. Okay, I go back to the history of mathematics from ancient Greece. In ancient Greece, mathema means the subject of instruction or learning. Any subject of learning, okay, any subject until A6, it is called mathema. Mathema means sema of learning, okay? However, it is limited in the case of, in the process of Roman Empire, it is limited to music, astronomy, and arithmetic and geometry. And this is the book of harmony by the Ptolemy, okay? Harmony, okay? Claudio Ptolemaios, okay? And this kind of thing is a mathematics. The reason why is that for developing the music scale, okay, we have to divide appropriate into the chord. We have to divide into the chord appropriate ratio or fraction, okay? Anyway, figural representations And Latin language was a key at that time, and then become algebraic representation. And currently, we are teaching mathematics by using algebraic representation. However, now on the era of computational thinking, computational and visual representation we can use, because AI can be used by the natural language. Anyway, the representation is the key. What kind of representation or language we use in mathematics? Okay. Okay. And this is the C-based CCRLS. Southeast Asia endorsed by Southeast Asia Ministers of Education Organization curriculum framework for the curriculum specialist and teachers. Okay. We discussed the curriculum specialist and developed this diagram as for the framework for the mathematical thinking. And when we say mathematics, we usually focus on the content. At the same time, we say higher order thinking. What is it? Okay. Those components are necessary components for the human character in general. And it is, we are teaching through the content, we try to develop generally meaningful idea, ways of thinking, values, and attitude for human character formation. That is mathematics education. However, we usually focus on acquisition of content. Why? It is necessary for us. However, we would like to develop mathematical thinking. Okay? How can we develop it? We can develop it through the reflection. Okay? We can develop mathematical thinking through the reflection. How can we develop value and the attitude? Appreciation. Through appreciation. How nice his idea. Appreciation. Such a things for the we may need to consider the ways of reflection and appreciation in the teaching process of mathematics. How shall we do? Such a discussion is written in this booklet. It is published by the CML Lexham, and the newest editions, second editions are collaboration of the CML Kuitep in mathematics in Indonesia, Yogyakarta. And okay, there are for the reflection and appreciation to teach mathematical thinking and value and attitude. We may need to consider the context because we have to reflect on the process. Okay? And here I would like to focus on task sequence. Other way is that mathematical modeling. Okay? However, I would like to focus on task sequence because I would like to discuss mathematical ideas and the ways of thinking and so on. Okay? And mathematical thinking can be developed through task sequence for using what student already learned and the preparation of necessary representation for future learning. Okay? We use student already learned. Otherwise, we cannot teach it. However, at the same time, we prepare the future learning. Okay? What is it? It is a preparation of the representation which we will use later. Okay? So, this is mathematical thinking. And then I'd like to discuss about computational thinking. I've been engaged in the APEC project more than 20 years. And this is a report from the APEC project. And it is also the product of curriculum specialist. Okay? We have the meeting in Chile, and with curriculum specialist, we discuss the framework for the computational thinking. And historically, until 10 years ago, programming thinking was the key. Currently, of course, yes, still key. However, on the era of AI, it looks already old-fashioned, only focusing on programming thinking. However, it is still necessary. Okay? And through such a discussions, we developed 3 pillars. Computational model, machine learning. Machine learning means using the AI and developing AI, and programming or coding. Okay? And based on those 3 aspects, we may need to develop the content of teaching for the computational thinking. Okay? And recently, we developed guidebook, CMS STEM Ed, and SIGIM, and the Lexam, and Simulec, also with collaborations, we developed guidebook for unplanned computational thinking. We can develop computational thinking without using computer. Okay? Okay. Okay. Okay, could you read this task?
Yes, we can read it.
Is this mathematics? This is
Yeah.
fixed for mathematics content, okay? This content is prepared for the kindergarten and early 3 months of the grade 1, okay? Of course, we can use it in mathematics, but we can use it in art and the other subject, okay? And this is task A. Can you imagine task B? Next task, we may need to consider the task sequence. And then what is it? Nothing written. Okay? So the structure of this task sequence is like this. They do some activity, at least 2 blue balls. The difficulty is at least. 2 blue balls is possible. Okay, any 2 balls in the box. But at least means more than. It is including the idea of set, inequality. Okay. Anyway, such as ideas, student fill in the color and then discuss. I colored something, blah, 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 blah. Then discuss. But your expression is not exact. Such a critique is possible. If you are, I also like all, for example, in the presentation, some students say, I paint blue only. Okay, it is a problem. All students are blue. Okay, so we have to explain exactly. Such an experience we do at task A, and then task B. They have to fill in the box. It means that they have to pose the question to the others. Okay? For this, they have to reflect on everyone's presentation. We are enjoying the presentation. Oh, you're like that. Okay? However, for posing the new question, we have to think. There are many presentations. Some ideas are fine. I would like to use his idea. But I have to change such a thing. Something new, innovation. Okay? So this kind of the process is a way to develop computational thinking. Okay? For the programming, we have to use the word term exactly, appropriately. And for teaching machine learning, we have to consider the idea, that idea is a good example or not. Okay? We have to categorize and so on. Okay? Such activities are embedded in these activities. Okay? And I would like to back mathematical thinking. If it is possible to develop the general ways of reasoning, okay, general literacy, why we teach math? Why I go back to the content? We are teaching the skill. And many of the researchers say those parts are higher order thinking. What is it? Okay. We have to see the content from those perspectives, higher order thinking. But we have to say more exactly. Otherwise, we cannot make clear the objective of teaching in the class. Why you teach that? Why do you want to teach it? Okay, focus on content. And I usually use this example. Many of you may know this example. Okay, how many the smallest unit square in total? How many? Already you have the answer. Many of you already moved this unit square to there and say 3 times 9. Okay? Why you can do that? Okay? Mathematical ideas are hidden for the multiplication. It is idea of multiplication. For teaching multiplication, of course, we have to teach 3 times 9 or 9 times 3. Okay? Students should memorize. However, if you only memorize, it is not the teaching the content. To teach content, we have to think about the idea of multiplication. And the idea of multiplication is that any number can be a unit for counting. Any number can be a unit for counting. Okay? Here, we would like to set 9 as a unit for counting. Such a thing is that to see it by the multiplication. To see it as mathematically. Okay? We usually say thinking mathematically. However, for that, when we teach the content, we have to teach mathematical ideas belonging to every content of teaching. Otherwise, students cannot use multiplication in their life. Okay? Okay. So another necessary things. This is the kindergarten activity. No meaning for math. Such a discussions are disappointed for me. The reason why is that if you have the good grasp for the mathematics, if you can see it from the perspective of mathematics, okay, we can see various things. When we discussed with the Dr. Sumardio, director of SIKIM, Semi-Equitable Mathematics, he just said, oh, it is matrix. Okay, can you see this painting activity from the perspective of matrix? If you can imagine this blank part, the question might be very much changed. Okay? Such a view way to see the situation by the mathematical ideas which belonging to the content. We have to teach it. Okay? And at the same time, we should teach more general ideas which can use, even we do not use math, we can use the ways of thinking and the value and attitude. Such a thing we should teach by using through the teaching of content of mathematics. Okay? Okay. Then in this guidebook, and is actually many examples are accepted from this book textbook, Japanese textbook. And actually, you have in your textbook, Bahasa Indonesia, this kind of example can be seen. Okay? For example, how this is a very much simple problem as for the primary school level teachers. But from the mathematics perspective, we can see it more higher viewpoint. Okay? For example, this task. This task is known in informatics as the Chinese postman problem. And there is a discussion of what kind of algorithm is better. Okay? Mathematically. Okay, there are many things. We can see it more higher perspective. So it means that preparation for the future learning. Those representation, all of them are preparation of the future learning. Okay? And this is a current newest edition of the Gakko Tosho textbook. It is written, this kind of things are written at the second grade for second grade student at the primary school level. Okay? And if you teach this, what do you want to do next after this task? Okay? Normally, we would like to add one more, right? And move it. And through this kind of activity, we can find the algorithm. Algorithm is a kind of mathematical ways of thinking to develop algorithm. Okay? Okay. And I would like to back to your textbook. Now, let's think. On this textbook, on your textbook, it is written. Could you see this? This is a review of the second grade content. Second grade, they studied this. And then third grade, they study 3 digit plus 3 digit. And they already learned until here. Okay? All these examples if you read it, no carrying. Which one is carrying once? Which one is carrying twice? Okay, that is the question, right? Okay. And then let's plan the order of your challenges. It means that teaching or learning for yourself. Okay. For student is learning sequence. From the teacher's perspective, it is teaching sequence. And for the planning the task sequence, it is challenges for the math educators. Math educator need to establish appropriate task sequence. How can you develop it? Okay. Sorry. Which one already carrying once? No carrying, sorry. Those are the 3-digit number plus 3-digit number. And no carrying. Okay, no carrying. Okay. Then, which one is no carrying? No carrying is already learned. Carrying once, which one is carrying once? Which one is carrying twice? And what order we would like to develop the teachers who pose the question to the student. Which order shall we learn? Okay? Which order shall we learn? Of course, at the beginning, various possibilities because students do not know the ways. Challenges from the carrying twice. Okay, such a discussion. And anyway, we can confirm this is carrying, one-time carrying from the ones place. And the next one is tens place carrying. Okay? And the next one is carrying twice. Okay? Such a thing is the order of teaching or order of learning. And if students are able to plan the ways of learning, ways of thinking, ways of plan the order of learning, okay? Such a discussion. And for students, what is next opportunity for the planning? If this is on this task sequence, it is a task sequence, but for training the student who are able to think, by themselves, okay? We may need another further opportunity. And actually, can you imagine the next opportunity? This is the case of the plus. Yes. Next case is minus, okay? If they experienced, they can imagine the next task sequence. And such a thing is analyze process for planning, okay? Such a thing is a kind of mathematical attitude. Okay, ownership. Our students have the ownership to plan the learning for themselves. Okay? And I just want to confirm, this is your textbook. You can download from the ministry, the website. Okay? Could you check at first, could you plan the order of teaching and learning, task sequence? And could you check by yourself through the download the textbook? Okay? Okay. And I would like to go back to the, it is a kind of mathematical thinking. And your textbook have the many things, many ideas and ways of thinking can be developed. and represent with using the representation. Okay, please check your textbook. And this is a task in the guidebook. Okay, this is a lottery. This part are hide basically. This part are hide. So without this horizontal bar, go straight. But if we would like to change after the open the lottery, we can add. Okay. And the question is like this. Both of them get the Porsche. Okay. Okay. Then on this lottery, he failed. But he can add one. Good idea. Okay. Now, he can got the Porsche. All right. Sorry. Okay. We add. Oh, he still cannot get the Porsche. Oh, what happened? Anyway, if we add 2, or more, it can. Anyway, the discussion. If we add 1, what will happen? The course, the route will change. Okay? Then, if I add one more, he add one more. It does not change. Okay? 2 more does not change because it's go like this. It's go like this. Okay? Okay. Then here, if we add many things, it's just complicated. Let's think minimum cases, which change the order from left right to right left. Okay? This task. Pigeon. He wanna get pigeon. She wanna get dog. She wanna get cat. She succeeded. Others are wrong. And we should add the bar. Okay? Did you imagine? Okay, like this. Then he got the pigeon. But however, she got the cat, she got the dog. Then say no. Okay? How shall we do? How? Add 1. Then she got the cat. She got dog. Or it is happy. Okay? Such a discussion. And then what is the next? 2 bar, 3 bar, 4 cases, 4 bar. Pigeon, dog, cat, bicycle. Bicycle, cat, dog, pigeon. Okay? Left, right become right, left. Okay? How shall we do? Okay? We don't have time. I just show you the result. This is the result. Okay? Okay. Then blank. What do you want to do next? What is the next task? Could you pose the question? Posing the questions are necessary to use ChatGPT. Okay, generative AI. So we have to develop the student who pose the question. Okay, this is, for example, okay, left to right become right to left. Okay, so many. How shall we do? Wow, so many. Let's reflect on what we learned. Let's reflect on what we learned. We learned this. What kind of things you can find?
Sequence.
Okay, sequence. Yes. Here goes to there. This one goes to there and add it. Okay? This embedded here, this embedded here, and then can you imagine next? Okay, such a thing. Okay, this kind of things are inductive, analogical, and deductive reasoning. Okay? Of course, we can teach this reasoning by using your teaching content. But even though, actually, I never use the number here. Even we never use the number, we can teach inductive reasoning. And beautiful pattern. Beautiful, right? When we say beautiful in mathematics, it means that invariant, there is an invariant structure. If we find the invariant structure, it is beautiful. And the pattern, recursion, and invariant, ordering, maximum and minimum, and symmetry. This is a symmetry. Those things can be learned through this example. However, if we stop this, not enough. Okay? And algorithm and something. And the next task. Could you read? I don't have time, so I will skip. However, could you read the task? This task is posed by the ICM, Semiocritic Mathematics. So in Indonesian teachers may be familiar this task, okay? Only allowed to go this manner, and how shall we go, okay? Two root, and one step, two step, one step, two step, okay? Can you imagine how many? And can you imagine in this case how many roots and how many steps? One step, two step, three step, four step. One step, two step, three step, four step. Step is the four. Okay, anyways. However, how many roots? Okay? Okay. By using this task, what kind of value, attitude, idea, and ways of thinking you would like to develop? Okay? Okay, then I just say would like to show some, okay? Two root, two steps. Then when my first trial, it was 5 root. However, I find it later, it has 6 root. In this case, I thought 5 root, however, I'm missing this one. Okay, it is 6 root. And can you imagine my next question? Okay, there are many questions I skip. Okay, then this is the case of 2 by 2. This is the case of 3 by 3. And I try to solve the case of 4 by 4. However, I couldn't sleep. For the primary school student, I feel necessary to draw. However, I couldn't reach mathematical answer. I know the answer by mathematical reasoning. However, I couldn't draw. It is 20. Answer is 20. In the case of 4 by 4, there are 20 roots. However, I only can draw 15 roots. Then I couldn't sleep. Mathematically wrong, or my drawing number of cases 3 diagrams are wrong. I couldn't sleep. Then I do something inductively. Okay? One case, two case, three case. Okay? Then four case and five case. Okay? And then go there. How shall we do? Basically, this part is 3. From here to there, 3 possibility. It is written here. Then this one. From here to there, 3 possibility. Then, oh, and then I checked my mathematical answer by the other way, and then I recognized, oh, I may need to consider the ways of actual drawing, the root. Anyway, on this task, root should be 20 times and or 6 times and 2. Okay, multiplication and the step should be add. Anyway, okay. Any ways of and I consider the other ways of representation. Okay, this from here to there is 1. From here to there is 1. Then here 2. Okay, on this manner, I embedded the previous one. This is the same. Then 1, 1. Okay, one way, only one way. Then 3, 3. To go there, addition of 1 and 2 is 3. Okay. And then 6. Okay, okay. Then embedded and this one and get like this. What is it? What is it? This number. What is this number? 1 plus 3 is 4. What is this number?
4.
4. Yes, 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 yes. Yes, 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 yes. Yes, 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 yes. Okay. I have a question. Have you ever met before by the word of David Toll, who passed away? He said this kind of things met before. Where did you met before? This idea. Okay. Add this and this is 3. Add this and this is 6. Okay. This is Pascal triangle. Wow. And then other way, using the step. There are various ways of step. And we can represent these arrows. Oh, sorry, I made a mistake. This is L. Left, left, down, down. Oh, sorry, left, down, left, down. LD, LD, sorry. And then it is a duplicate of permutation, then it is done. Wow. Then this part is this one. Oh, did you know that? Okay, such a thing I found by myself. Thank you very much. And such a manner, okay, go back this task again. The repetition, but embedded the previous idea to the next, previous drawing to the next drawing. Such a things, we call it recursive reasoning. Recursive reasoning is here, okay? Repetition of the task sequence of the recursive reasoning. We can develop it. How do you say recursive reasoning in Bahasa Indonesia? Okay? It is necessary for the programming and how do you develop recursive reasoning? The answer is like this. Reflection and appreciation. Wow. And by using what already learned, through the preparing further representation, and change representation for mathematization. Okay? Change the representation is not easy. Okay? Original drawing is likely this, or likely this. And it should be called left, left, down, down. L, L, R, D, D. Okay? And such a thing as this one. And it is the part of this part. Okay? Such a thing. Change representation. It is mathematization. Find new mathematical structure, meaning. Okay, thank you very much. I skip. I almost talk. Okay. So today I talk about the ways of development of mathematical thinking and computational thinking. And such a things are already embedded in your textbook. However, I show the other example. The reason why is that new example can be recognized. The repetition of task sequence is necessary to develop mathematical thinking and ideas and value and attitude and so on. Okay? And then second edition of the mathematical thinking framework will coming soon, within a month. And coming soon is that I'm now developing with Seeking encyclopedia for lesson study by using textbook. It is explanation of the task sequence in the textbook. Okay? We have to know what is learned and what is the preparation for future. For that, we have to have the know the task sequence of the textbook. We are now developing encyclopedia by using the terminology which explain various ideas and progress of ideas. Okay. And finally, I'd like to collaborate some of you who would like to contribute. We are now preparing teaching fraction and proportionality. It is the next book of multiplication. After that, multiplication division come, but it is fraction. Okay? Thank you very much for today. Okay.
All right. Thank you very much for your insightful presentation, Professor.
Thank you very much.
Maybe we give a big applause first. And now we still have time for a question and answer session. So I will invite all of the participants to raise question, either for attend this conference in person or the one in the Zoom meeting. So please raise your hand if you have question, or you also can to type the question on the chat box. So in-person participant, Bapak Ibu silahkan. Yes, we have one question. Maybe for this term, I will collect two questions first and let Professor Isoda to answer. Please introduce yourself and the institution. Yes.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you, Prof. Isoda about your explanation. I'm interested for your next coming book, Encyclopedia for Lesson Study by using textbooks. Would you like to explain it to me about what kind of information that you wanna explain in your encyclopedia? Because I'm interested in lesson study also. In Indonesia, we already apply the lesson study. Thank you, sir. I am Fitrani Dwina from Universitas Negeri Padang.
Oke, terima kasih Bu Vera. Thank you for the question, Ma'am Vera. Is it okay if I collect one more question, Professor, and then we will answer both of the question.
Yes.
The second question, please. We have here on the floor, I think. Or okay, we wait for the second question. So you can start to address this question, Professor, please.
Okay. Thank you very much. I will share the screen. Okay. On the book of multiplication, this task sequence is written. And every time the meaning of multiplication changes. At the beginning, accumulation or repeated addition is the meaning of this multiplication. However, later, accumulation is not the meaning of multiplication, and so on. So such a process of changing was written like this in this booklet, in this book. And the further preparation, currently we are engaging in it, this kind of diagram. In your book, in your textbook, at the first grade, chapter 2, in chapter 2, first grade, composition and decomposition of numbers, activities existed, okay? And it is 10 is 1 and 9, 1 and 9 is 10. 6 and 4 is 10. 10 is 6 and 4. Such a thing is the composition and decomposition of numbers. And when we see 10 and 3, remaining is 7. Such a thing is in English, I forgot the supplement, a complementary number. Such a thing they study at the beginning. And then by using that, addition up to then, they study composition of numbers. Okay, they study composition of numbers. And on the subtraction, they use, they studied composition and decomposition of numbers at first, and when they study addition, instead of counting, they can get the answer of addition of the two binary operation. They can get the answer by the composition of numbers because they already know 3 plus 4, 3 and 4 is 7. They already learned. So for them, without counting, they are able to get the answer. And on the subtraction, they use the decomposition of numbers. Okay, decomposition of numbers. 7 minus 4, it is a complementary. Complementary number is 3. 3 and 4 is 7, and 7 is 3 and 4. So such a thing is a decomposition of numbers. Then, on the other hand, the meaning of addition changes more than 10. More than 10, they have to carrying and they have to borrowing. Okay. However, it is not a vertical form yet. They have to use, they only can use is this idea. But the addition meaning is change. We have to making 10. The reason why is that we discuss about the counting tens. Tens place and ones places are represented by base 10 place value system. So we say 30, it means that 3 tenths. Okay. So anyway, on that format of writing, we have to, students have to think about making 10 and use the meaning of addition, change the composition of addition and the composition of, the composition of addend and then composition. Such a process appeared. So here, only composition of numbers means addition. However, addition more than 10, we have to use both ideas. So the addition meaning changes. So such a process, we would like to, in encyclopedia, we showed this kind of map. And by using Bahasa Indonesian edition of the textbook, and then we explain some terminology to distinguish the ideas. Here, the composition of the composition of numbers are necessary ideas to explain the progress of the meaning of addition and subtraction. So such a thing is the content of the encyclopedia. Thank you very much.
All right, thank you for your response, Professor. How about the answer, Bu Vera?
Okay, thank you, Prof. Isoda. I'm glad about your explanation. And my next question is, how can we get your inscription?
And we have the lesson study activity last August and this last one year ago August and the last August. And the video clip existed online. Okay, so if you saw the video clip, there are explanation of task sequence, first grade and second grade and third grade sum. Thank you very much.
Okay, thank you, sir. I'll try to find it.
Okay, thank you, Ibu Vera, and thank you, Professor, for your response. We have one question from the online audience. So if you don't mind, I would like to invite Pak Gali to ask the question. Pak Gali, you can turn on your camera.
Good afternoon, everyone. Thank you for the opportunity. Let me introduce myself. My name is Gale from UIN, Said Ali Rahmatullah Tulungagung. I have one question. In many occasions, I met some elementary students. They solve exploratory problems by ChatGPT or by Photomat, and I think it is a negative way to solve that problem. Would you explain how can we prevent it, or we can use it to gain some benefit to learn something? I think that's all from
Thank you
me,
very much.
Professor Masami. Thank you.
A good question, but myself, I want to develop a student who say, do not say answer. Okay? I wanna think by myself, just wait. In so many cases, teacher shows the ways of solving. And ChatGPT and generative AI also can produce some explanation. And of course, we are able to use it, and we can develop the student. We should develop the student who critique even it's produced from the generative AI. However, at first, I will develop the student. Just stop. Actually, enjoyable mathematical activity is that point. Teacher knows everything, of course. But the teacher explain, then do it. On such a process, student develop mindset, I'm waiting. Teacher show us the answer. However, I would like to develop the student who say, just stop. I will think by myself. And the representation, it is Van Grossersfeld said, represent is represent in our mind. For represent, even ChatGPT give us some answers, nothing. Represent in our ideas, in our mind, represent. That is a necessary activity for everyone in mathematics. And through that, we can develop mathematical thinking. Thank you. Of course, now the ChatGPT or generative AI is a progress. So we cannot imagine 10 years later. However, at this moment, we would like to develop the student who can critique, pose questions to the ChatGPT. And at the same time, stop. I think such a student. Thank you very much. And may I add some information about the previous questions?
Yes, please. Yes, you can.
On the CRISED website, my center's website, there are a number of online lectures. And the book, here is a reference book. All of those books are free, download free. And on the lectures, for the terminology, for the encyclopedias, or it's already explained those first three courses, Mathematical Thinking 1, Mathematical Thinking 2, Mathematical Thinking 3, we explained primary school levels necessary terminology which should be used for the lesson study. And so on this, if we have terminology, we don't need to say concept. If we say concept, teachers cannot imagine what it is. And even myself, I don't well understand the concept of number. Of course, I know the concept of number on the meaning of pure math, how to construct from the pair nodes action until the real number and until the complex number. However, I don't know the concept of number. But we can say denominated number, numeral, many words should be focused on some mathematical content. Okay. So such a thing that can be seen on this, you can know from those lecture series. It is free. Thank you very much.
All right.
Now, Indonesian edition we are developing. Thank you very much.
We are waiting for the Indonesian version of that.
Yes. And for that, your collaboration is necessary. Because some words are not existed in Bahasa Indonesia. So you have to create understandable word for teachers. Thank you very much.
All right. Thank you, Professor. And thank you, Pak Gali, for the question. Do we still have time to the Q&A session? I think we still have one more spot. So if there is one more question from the audience, please raise your hand. Either in the Zoom meeting or the participant in person in this room. I saw someone raise a question from Niken, Bu Niken. Halo?
Ya, halo Pak.
Ya, silakan.
Oke, saya izin bertanya menggunakan bahasa Indonesia ya Pak. Mungkin nanti bisa ditranslate because my English so bad. Sorry. Oke, perkenalkan saya Niken Sulfayanti, salah satu mahasiswa yang baru lulus S1 pendidikan matematika dan sekarang sedang menempuh eh, sedang menempuh pendidikan S2 pendidikan matematika juga. Nah, selain itu saya merupakan guru di salah satu bimbel atau bimbingan belajar di Jakarta. Nah, di mana selama saya mengajar itu sudah 2 tahun saya mengajar di sana. Saya seringkali mendapatkan pertanyaan dari siswa saya mengenai soal-soal yang diberikan dari sekolah. Nah, soal-soal yang diberikan dari sekolah itu udah merupakan soal kontekstual atau yang berhubungan dengan dunia nyata. Jadi dengan harapannya soal itu kan bermakna bagi siswa gitu, bisa menghubungkan matematika dengan dunia nyatanya. Nah, tapi sering sekali saya temui bahwa siswa itu hanya memperdulikan bagaimana menyelesaikan soal itu gitu, menggunakan rumus yang tepat gitu. Tidak memperdulikan oh ini bakalan digunakan ke kehidupan saya seperti ini loh gitu. Nah, tapi hanya memperdulikan gimana cara menjawab soal dengan tepat saja gitu. Jadi kesannya makna dari soal yang sudah dirancang itu jadi hilang gitu. Nah, bagaimana seharusnya kita sebagai pendidik atau seorang guru nantinya untuk menekankan makna dari matematika pada konteks dunia siswa gitu. Memang matematika ini berasal dari dunia nyata gitu. Itu pertanyaan dari saya. Terima kasih.
Oke, terima kasih. Thank you, Bu Niken. So I will try to translate the question, Professor. So Niken is a new student at the master degree program for the mathematics education. Currently, he teach in not in the school, teaching mathematics in the like an academic or as a tutor, mathematics tutor. So usually the students ask the question, the mathematics question, only to solve it, to solve the mathematical task. What the question from Niken is how to make how to keep the meaningful mathematical task. I mean, how teacher keep the task being meaningful for the students. However, the student only want to solve the problem, asking the question to solve the problem. Is that your question, Uniken, or can you, because it's a very long talk, is it the question?
Ya, jadi intinya itu gimana sebenarnya soal yang sudah berbasis konteks itu menjadi bermakna bagi siswa gitu, bukan cuma untuk diselesaikan saja gitu.
Right. So design a contextual problem to let the mathematics meaningful for the students. However, usually the students only want to solve the problem without really understand the meaning or relate it with the contextual in their daily life. That is the question, Professor.
Yeah, and today I discuss about the mathematical task sequence part, and I didn't discuss the situation part, real world situation, likely mathematical modeling. And the reason why that I would like to focus on so that develop mathematical thinking. And in the case of the primary school level, for teachers, not easy to understand such a task sequence. That's the reason why we are developing the Bahasa Indonesian edition of the map and the explanation of the sequence. And the question is related with the how can student understand the situation as for his task. Task is usually given by the teachers and sometimes no interesting. However, so on that context, teacher make an effort to contextualize And it is good things and bad things. It has good things and bad things. Good things is that real world problem solving. Okay. And the bad thing is that sometimes student cannot see it mathematically. For example, on the addition task, in your textbook, there is such a this kind of task. In the big waters, there are three fish and two fish, and then coming in, okay? And then the question is how many in total altogether? That is the introduction of the addition. And in Thailand, I observed that the class. In Thailand, teacher prepared the big bowl and water and fish, and then put in. What they can do is only counting. And the difficulty is that if they try to do something, fish moves quickly. And it is a real situation. But 3 and 2 is 5 is a really discussion, what is necessary for us. And on that process, in the textbook, there is a picture is written. And then on the pictures, student put in the block. And the block moves. Then they discuss, oh, this is 5, okay? We would like to teach this activity, this join, 3 and 2 join, this is addition. Such a thing we want to discuss. And sometimes, if we begin to use such a concrete materials, likely the fish, really fish, okay, students enjoy, but they are not enjoying mathematics. So, real situation is a good things and bad things, okay? So we may need to think, what shall we focus on today's class? Of course, I don't deny the activity of the real necessary to develop mathematical ideas to join for 3 and 2 is 5. Okay, thank you.
All right, thank you for the answer, Professor. How about the answer, Niken?
Okay, thank you, Professor.
Right,
Thank you very much. Good question.
Good question. Yeah. The committee said to me that we still have one opportunity, the last question. So there are many audience enthusiasts with this session, but unfortunately, yeah, we only have one more question. So please, if you have the question, raise your hand. Someone in Zoom meeting? All right, yeah. Please introduce yourself.
Okay, good. Yes, good afternoon, sir. My name is Tiara. I'm master student degree from Universitas Sriwijaya, Palembang. I want to share something to you. In my college, we starting learning about computational thinking with my lecture, and we try to apply the city-based learning on student in a high school, but it seems so hard for the student. I want to ask to you whether city-based learning must always start with understanding concept or looking for the formulas, or whether it can be used in learning when the student already know about the material. Is that my question, sir? Thank you for the opportunity.
It's a difficult question for me that it is, I don't well understand your situation and context. However, in my lecture, what I would try to enhance is that importance and the necessity of the figural representation, figural drawing, mathematical representation such as sequence, especially I discussed recursive reasoning. And I had in the university, in the high school of Indonesia, you didn't teach recursive formula. Recursive formula is AN equal AN plus 1, AN plus 1 equal AN plus K or something. Okay? Such a recursive formula you study at the university. In the case of Japan, recursive formula study at the high school. Anyway, when we teach the mathematical representation, we usually imagine algebraic formula. And it is abstract, actually. And before that, teacher tried to use table. However, most of teachers forgot to analyze the concrete representation, figural representation. For example, we move like this, okay? We move like this. Then it is left, down, left, okay, down. Then L, D, L, D. All different representation. But if we reach LD, LD, we can apply the formula, algebraic formula. Before that, we have to think about the way to find the answer. Okay? So I use the figural representation and the repetition, previous figural representation can be embedded the next place. Then next place, the figural representation can be embedded the next one. Okay? Such a process is in figural representation, we can say recursive reasoning. So there are various representation, and between representation, we translate. Then finally, in my case, I find, oh, this is a Pascal triangle. Okay? And then, oh, this number is a duplicate of permutation. So various representation existed. And until which representation is meaningful for your student and enjoyable. And actually, through doing that, I couldn't sleep because I couldn't draw the concrete drawing. It's mathematically, I imagine it should be 20. However, 15, oh, this time 14. How many times I have to draw? I couldn't see. So such an enjoyable experience is also good. And in the case of Japan, we had the time for the exploration. In the first grade of high school, 2 hours in 2 hours in first grade, they can have the time for inquiry. Time for inquiry, they can choose by themselves what they want to inquire. Okay? So to develop mathematical thinking, not only the time is in your curriculum, we may need add the additional activity. Okay? Thank you very much.
All right, thank you for the response, Professor. How about the answer, Butiara? Do you have any feedback?
Yes. Thank you so much, sir.
All right, thank you. Professor, it's the end of our session, unfortunately. So Thank you very much for Professor Masami Isoda. It's a very nice presentation and also Q&A session. So as we approach the end of this session, I would like to present you with a certificate as a token of our appreciation from the ICM2E committee. Maybe the certificate for our keynote speaker. Yep. And the certificate will also be sent to your email shortly, Professor. Thank you very much. Give a big applause for our session.
Thank you very much. It is good chance and talk and work with Indonesian scholars. So let's collaborate. I'm looking to meet you on site. Thank you.
We will welcome you in Padang, West Sumatra, Professor.
Yes. Thank you very much.
Thank you very much. So this is the end of our second keynote session segment. To all our audience members, we greatly appreciate your attendance and engagement in this session. I now hand the floor back to our MC, Bu Rara Sandiwinanda. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih.
Terima kasih, Prof.
Thank you once again to Professor Masami Isoda and Rona Rifandi, MSc. Let's give him a round of applause once again for his valuable contribution. Now we will take a lunch break. Please return at 1:30 p.m. for the continuation of the plenary session. See you soon.
Selamat datang di Universitas Negeri Padang, tempat di mana masa depan cerah Anda dimulai.
Kembali saya ingatkan, kita isoma terlebih dahulu, lalu akan kembali lagi untuk sesi berikutnya pada jam 1.30. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. I am Professor Ganefri PhD, Director of
Selamat datang di Universitas Negeri Padang, tempat di mana masa depan cerah Anda dimulai.
Ya Bapak Ibu, untuk konsumsi makan siang disediakan di luar ya. Sudah disediakan oleh panitia.
Kami dengan bangga mempersembahkan program studi baru yang dirancang untuk memenuhi kebutuhan industri modern. Program studi S1 Ilmu Aktuaria.
Ilmu aktuaria adalah disiplin ilmu yang menggabungkan matematika, statistik, dan teori keuangan untuk mengelola resiko di berbagai sektor, terutama asuransi dan keuangan. Peluang karir dalam bidang aktuaria sangat luas dan beragam. Menurut Otoritas Jasa Keuangan, Indonesia membutuhkan lebih dari 1.000 aktuaris bersertifikasi untuk memenuhi permintaan industri.
Program studi ilmu aktuaria di FMIPA UNP menawarkan kurikulum yang komprehensif dan dirancang untuk mengasah keterampilan analitis dan pemecahan masalah. Anda akan belajar dari dosen berpengalaman dan ahli di bidangnya. Fasilitas kami lengkap dan modern, yang mendukung proses belajar mengajar yang efektif. Kurikulum kami juga mencakup 3 peminatan utama, yang memungkinkan mahasiswa untuk menyesuaikan pendidikan mereka sesuai dengan minat dan tujuan karir mereka. Peminatan tersebut adalah 1. Pemodelan aktuaria. Peminatan ini fokus pada pengembangan dan penggunaan model matematis untuk menganalisis dan mengelola risiko dalam asuransi, keuangan, dan bidang terkait lainnya. Mahasiswa akan mempelajari teknik-teknik pemodelan lanjutan dan aplikasi praktisnya. 2. Sains data aktuaria. Dalam peminatan ini, mahasiswa akan mempelajari cara-cara mengolah dan menganalisis data besar untuk mengidentifikasi pola dan tren yang relevan dalam aktuaria. Fokusnya adalah pada penggunaan teknik sains data untuk mendukung pengambilan keputusan yang lebih baik.
Ketiga, bisnis dan keuangan. Peminatan ini menggabungkan ilmu aktuaria dengan pengetahuan bisnis dan keuangan. Mahasiswa akan mempelajari manajemen keuangan, penilaian aset dan strategi bisnis untuk pengoptimalan keuntungan sambil mengelola resiko. Jika Anda menyukai matematika dan juga tertarik pada ekonomi, ilmu aktuaria adalah pilihan yang sempurna. Program studi ini menggabungkan keahlian dalam matematika dan statistik dengan menerapkan langsung dalam dunia keuangan dan ekonomi. Mahasiswa juga memiliki akses ke laboratorium komputer canggih, perpustakaan dengan koleksi buku yang lengkap, dan ruangan diskusi untuk mendukung kegiatan belajar.
Kami di FMIPA UNP berkomitmen untuk mencetak lulusan yang siap bersaing di dunia kerja global. Program ini juga memberikan jembatan kesempatan bagi mahasiswa untuk mendapatkan sertifikasi profesional yang diakui secara nasional dan internasional, membuka peluang kerja yang lebih luas. Lulusan ilmu aktuaria memiliki banyak pilihan karir, seperti aktuaris, analis risiko, underwriter asuransi, analis keuangan, konsultan aktuaria, manajer klaim asuransi, penasihat investasi, pengelola dana pensiun, dan aktuaris pemerintah.
Jangan lewatkan kesempatan ini untuk menjadi bagian dari program studi yang menjanjikan masa depan cerah. Pendaftaran untuk program studi S1 Ilmu Aktuaria dibuka dari 19 April hingga 10 Juli 2024. Untuk informasi lebih lanjut dan pendaftaran, kunjungi halaman web spmb.unp.ac.id/mandiri. Segera bergabung dengan komunitas kami di FMIPA UNP dan mulailah perjalanan Anda menuju karir yang gemilang. Universitas Negeri Padang mewujudkan masa depan cerah bersama program studi ilmu aktuaria. Tunggu apa lagi? Daftarkan diri Anda sekarang.
datang di Universitas Negeri Padang, tempat di mana masa depan cerah Anda dimulai. Kami dengan bangga mempersembahkan program studi baru yang dirancang untuk memenuhi kebutuhan industri modern. Program studi S1 Ilmu Aktuaria.
Ilmu aktuaria adalah disiplin ilmu yang menggabungkan matematika, statistik, dan teori keuangan untuk mengelola resiko di berbagai sektor, terutama asuransi dan keuangan. Peluang karir dalam bidang aktuaria sangat luas dan beragam. Menurut Otoritas Jasa Keuangan, Indonesia membutuhkan lebih dari 1.000 aktuaris bersertifikasi untuk memenuhi permintaan industri.
Program studi ilmu aktuaria di FMIPA UNP menawarkan kurikulum yang komprehensif dan dirancang untuk mengasah keterampilan analitis dan pemecahan masalah. Anda akan belajar dari dosen berpengalaman dan ahli di bidangnya. Fasilitas kami lengkap dan modern, yang mendukung proses belajar mengajar yang efektif. Kurikulum kami juga mencakup 3 peminatan utama, yang memungkinkan mahasiswa untuk menyesuaikan pendidikan mereka sesuai dengan minat dan tujuan karir mereka. Peminatan tersebut adalah 1. Pemodelan aktuaria. Peminatan ini fokus pada pengembangan dan penggunaan model matematis untuk menganalisis dan mengelola risiko dalam asuransi, keuangan, dan bidang terkait lainnya. Mahasiswa akan mempelajari teknik-teknik pemodelan lanjutan dan aplikasi praktisnya. 2. Sains data aktuaria. Dalam peminatan ini, mahasiswa akan mempelajari cara-cara mengolah dan menganalisis data besar untuk mengidentifikasi pola dan tren yang relevan dalam aktuaria. Fokusnya adalah pada penggunaan teknik sains data untuk mendukung pengambilan keputusan yang lebih baik.
Ketiga, bisnis dan keuangan. Peminatan ini menggabungkan ilmu aktuaria dengan pengetahuan bisnis dan keuangan. Mahasiswa akan mempelajari manajemen keuangan, penilaian aset dan strategi bisnis untuk pengoptimalan keuntungan sambil mengelola resiko. Jika Anda menyukai matematika dan juga tertarik pada ekonomi, ilmu aktuaria adalah pilihan yang sempurna. Program studi ini menggabungkan keahlian dalam matematika dan statistik dengan menerapkan langsung dalam dunia keuangan dan ekonomi. Mahasiswa juga memiliki akses ke laboratorium komputer canggih, perpustakaan dengan koleksi buku yang lengkap, dan ruangan diskusi untuk mendukung kegiatan belajar.
Kami di FMIPA UNP berkomitmen untuk mencetak lulusan yang siap bersaing di dunia kerja global. Program ini juga memberikan jembatan kesempatan bagi mahasiswa untuk mendapatkan sertifikasi profesional yang diakui secara nasional dan internasional, membuka peluang kerja yang lebih luas. Lulusan ilmu aktuaria memiliki banyak pilihan karir, seperti aktuaris, analis risiko, underwriter asuransi,
Assalamualaikum warahmatullahi wabarakatuh. Selamat datang di Fakultas Matematika dan Ilmu Pengetahuan Alam, salah satu dari 8 fakultas yang ada di negeri Padang. MIPA didirikan dengan bendera warna biru, yaitu warna dengan penuh semangat. Dalam menjalankan tugasnya, dekan dibantu oleh 3 orang wakil dekan. Dalam mencapai cita-citanya mewujudkan fakultas unggul, MIPA memiliki visi menjadi salah satu fakultas unggul dalam ilmu kependidikan dan ilmu MIPA tahun 2020 berdasarkan iman dan takwa. Untuk mencapai visi itu, MIPA menentukan menjadi 5 misi, yang kelima itu terangkum dalam bentuk kegiatan tidak maaf perguruan tinggi. Assalamualaikum warahmatullahi wabarakatuh. Selamat datang di Fakultas Matematika dan Ilmu Pengetahuan Alam, salah satu dari 8 fakultas yang ada terselit di Padang. MIPA didirikan dengan bendera warna biru, yaitu warna dengan penuh semangat. Dalam menjalankan tugasnya, dekan dibantu oleh 3 orang wakil dekan. Dalam mencapai cita-citanya mewujudkan fakultas unggul, MIPA memiliki visi menjadi salah satu fakultas unggul dalam ilmu kependidikan dan ilmu MIPA tahun 2020 berdasarkan iman dan takwa. Untuk mencapai visi itu, MIPA menentukan menjadi 5 misi, yang kelima itu terangkum dalam bentuk kegiatan tidak mampu perguruan tinggi. Assalamualaikum warahmatullahi wabarakatuh. Selamat datang di Fakultas Matematika dan Ilmu Pengetahuan Alam, salah satu dari 8 fakultas yang ada di negeri Padang. MIPA didirikan dengan bendera warna biru, yaitu warna dengan penuh semangat. Dalam menjalankan tugasnya, dekan dibantu oleh 3 orang wakil dekan. Dalam mencapai cita-citanya mewujudkan fakultas unggul, MIPA memiliki visi menjadi salah satu fakultas unggul dalam ilmu kependidikan dan ilmu MIPA tahun 2020 berdasarkan iman dan takwa. Untuk mencapai visi itu, MIPA menentukan menjadi 5 misi, yang kelima itu terangkum dalam bentuk kegiatan tidak mampu perguruan tinggi.
ada dok. Pada dulu tanya aja.
Di tengah. Ah iya iya. Kan aku di situ. Moderator.
Ya, moderat.
Coba Pak. Apakah tadi udah jadi tampil? Coba Pak live.
Bu. Iya. Letaknya udah. Bu, aku di mana, Bu?
Ayo. Langsung ke situ. Enak ayo di sini. Ya, laptop. Kayu tak sabar loh. Ya, aku jadi sesak pipis. Ladies and gentlemen, welcome back. We hope you had a pleasant lunch. Now, let us proceed with the next plenary session. Our next speaker is Dr. Mira Parmadawi, SSI MCOM, who will be presenting in person. The session will be moderated by Ms. Riwahyu, SPD, MSI. Please give a warm welcome to Dr. Mira Parmadawi, MCOM, and Ms. Riwahyu, MSI.
Thank you very much, ladies and gentlemen. Welcome to this session of keynote speaker of the 7th International Conference on Mathematics and Mathematics Education. Good afternoon, I'm Sri Wahyu. I'm going to be the moderator for this session. So, I would like to welcome our keynote speaker for this session, Dr. Mira Parmadewi. She is already with us. Hello, Bu Mira. Good afternoon. How are you today? Okay. All right. It is my great pleasure to introduce our keynote speaker to you all. Bu Meira is the lecturer in Mathematics Department, Universitas Negeri Padang. Her expertise is in the mathematics and computation, with a prolific background in both theoretical and applied research. Bu Meira's work has significantly advanced for understanding of complex system and algorithm. And she has made substantial contribution to interdisciplinary projects that bridge mathematics with technology. Some of her research are related to the similarity measurement of human DNA profile using fuzzy similarity, and then triangular fuzzy number for similarity measurement Y chromosome DNA profile. Next, images segmentation using minimum spanning tree, and then similarity measurement of segmented images using Euclidean distance method. And next, human DNA profile identification using DNA database system. So, today, Bu Maira will have 45 minutes presentation, and then we will have 15 Q&A session. And here we go, Bu Mira, please, it's your time now.
Okay, thank you, Ms. Sri Wahyu. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. It is my pleasure to stand up here in front of you to present my research about human DNA profile identification, entitled The Application of Mathematical Computing for Identifying Human DNA Profile. Okay, mathematics is a science that closely with the another science. It related to statistics, determining, information retrieval, machine learning, modeling, bioinformatics, and so on. This research is inspired by the diversity of the ethnic of our country, Indonesia. Indonesia is a pluralistic country consisting of many ethnic groups like Minang, Batak, Javanese, Sundanese, Papua, Minahasa, and so on. Each tribe in Indonesia has a uniqueness that is influenced by DNA structure. This can be seen in terms of the physically and genetic. Okay. This is the picture of the tribe of the Indonesia with their uniqueness. In other hands, our country, Indonesia, there is so many quiet, vulnerable of natural disaster like earthquake, tsunami, and terrorism attack. Not infrequently, the victim cannot be identified due to the partial or complete damage to the victim body. To help Indonesian authority to identify the victim, we can use the DNA profile. Unfortunately, our country, Indonesia, doesn't have a database system that saves Indonesia DNA information. Okay, let's continue. The problem statement of this research is hard or difficult to identify the victim of disaster and terrorism using physically characteristic or the fingerprint of the victim. So DNA profile, DNA profile identification is required to handle it. The best reference to identifying is the biological parents. But unfortunately, there is no information about the parents, or we can say that parents not found. So the DNA profile from the biologic family or tribe is needed for the identification of the victim. DNA is the oxyribose acid. It's like a human biologic identity. DNA is composed of 4 nucleotides that there are adenine, cytosine, guanine, and thymine. DNA profile describes short tandem repeat, or we can call STR. The STR is repeating pattern of nucleotide consists of 2, 4, 6 bases repeated without any changing in the human DNA profile. The STR sequence is a DNA has very high variation in individual groups or population. So it's making an excellent method in forensic identification. To obtain the DNA profile, we should get the source of the DNA, or namely evidence. The source of the DNA profile can be found in blood, sperm, hair, teeth, saliva, urine, bone, or muscle. DNA profile consists of 27 loci based on combined DNA index system issued by FBI Forensic Laboratory. The DNA profile describes STR value of 27 locus in human, where each locus consists of 2 allele. In extraction process in DNA identifying, the evidence DNA or the source of DNA will process by PCR machine, and then it will produce the electropyrogram as the result. Electropyrogram will describe the DNA profile of human. This is the 27 loci of DNA profile. Everybody have the 27 loci DNA profile, but in this research I use only 15 loci in DNA profile, because amelogenin is not the STR value that using integer, but the characteristic because it determines the gender of people. XX for female and XY for male. And then we don't use the YSTR or Y chromosome, because the Y chromosome only owned by male. Due to the victim of the disaster or terrorism attack can be male or female, so we decline it. This is the example of human DNA profile of someone. Everybody have this loci, amelogenin, CSF1, PO, and so on. And the allele one allele of us is obtained from our biological father, and the other one we can obtain from our mother, biological mother. As we know, this is the example of the picture when we use this DNA profile identifying for paternity DNA test. That one allele we get from our father, and other one we get from our mother. This is the picture of our design system. We have 3 stages here. The first one, when disaster happened, this is the stage 1. When disaster happened, the DNA profile of victim will obtain, and then DNA profile of victim will be analyzed, and the data DNA profile will save to the database system. And the second stage is the data collection stage. We get DNA profile of the population, and then population DNA will be analyzed, and it's saved to DNA database after clustering process. This is the third stage that is DNA matching stage. Here we have interface of DNA matching that connect to DNA databases, and then we have similarity module between interface and databases that will measure the similarity of DNA profile between the query and the database system. Query is the victim of the disaster or a terrorism attack. Unweighted playgroup method with arithmetic mean is a simple agglomerative hierarchical clustering, or we can say a bottom-up method that we can use for clustering of the population of the small tribe in Indonesia to be the biggest one. UPGMA is a simple that will structure the root tree or dendrogram, or we can say phylogenetic tree, that reflect the structure present in pairways. Cluster merging is based to the distance of the data set. We'll calculate based on this formula. Okay, this table describes the distance of two tribes, namely A, B, C, D, E, F, and G. Table 1 is number of the population that cluster A. The cluster A have 14 people, B 15, and C 12, D 11, E 10, F 12, and G 16 people. 42 is described the distance of the tribe A to B. 43 is described the distance of the tribe A to the C. From this distance, we can make the new tribe. The new tribe from 7 tribes to be the biggest one, and we got the dendrogram. This dendrogram or phylogenetic tree describe us that 7 tribes and become 3 tribes as a final cluster. From this dendrogram, we have the 3 tribes as a final, that tribe A, D, and G is the first cluster, and the second cluster consisting B, F, and E. Therefore, the C is a cluster in the third tribe. When we have the DNA profile of unknown victim, next step we can identify biological using DNA profile of cluster tribe as a reference. To calculate the similarity of DNA profile, we use fuzzy similarity measure. And because fuzzy was chosen to accommodate the uncertainty shift of the STR value generated by the PCR machine, which could be caused by several factors. Fuzzy similarity measure calculate the similarity of 2 allele in 15 loci of 27 loci at the total in human DNA profile. The STR value of the DNA locus will be represented as the middle value of isosceles triangle. Okay, this is the example when I represent the allele of locus to the isosceles triangle. where the T represented the similarity value of two allele that measure. This is the membership function of our input variable that it consists of three variables, which is small, medium, and large. The formula to make the membership function is in front of you. Okay, next. This is the membership function that can we make as a fuzzy rule if then else from the input and the output variable. We can arrange the fuzzy rule to decide the output result of the fuzzy similarity value. Those value will range 0 and 1. Figure 1 is the intersection of two allele that have 0.2 difference value, so that the similarity value is 0.5. And the second picture is the intersection of two allele that have different STR value more than 0.2. If two allele don't have intersection of STR value, the result of the similarity measurement is 0. This is the process to calculate the similarity of one record in a tribe. We get the similarity of allele1 and allele2, where allele1 have the similarity 1 and the allele2 have similarity also 1. So the similarity for this locus is 1. Where the similarity of locus, we can get that we obtain the similarity of one record and then divide 15. This will produce the similarity value for the record is 0.9968. When the similarity more than 0.5, we can say that this is the high similarity value between two data sets that measure. After all the process of the measuring DNA profile, the DNA profile similarity to all the tribe in a data set or databases, then the process will give the three record with highest similarity value as the result. The first record has the similarity value 0.968, and the second one have the similarity value 0.343, and the third record will have the similarity value 0.327. I'm so sorry, 8. From the second and the first record, we can conclude that the similarity value, the highest similarity value is the record 1. So when we choose the highest similarity record and the data of the victim or query will get and obtain. The information of the query can we get, and then the identification is finished. Okay, that all my presentation for today. Thank you for your attention, and feel free for any question. Thank you.
Okay, all right. Thank you very much, Bu Maira. Maybe we can give applause for Bu Maira. Your presentation is very good and interesting. I'm sure that many audience want to know more. As Bu Maira say that we can open Q&A question. So who wants to ask to Bu Maira, please raise your hands or type your name in chat box. Anyone here? Or on Zoom room? Okay, please, Miss Bevina Handari from UI.
Yeah, thank you. I just want to ask about the membership function, how you can determine the function.
Okay. Okay, is it your question is enough?
Yes, I saw
Maybe
there is three function, membership function, but I want to know more about how you determine the function. Thank you.
okay, thank you, Miss Bevina Handari. Bu Maira, you can answer. Up to you. What do you want? You want to answer or collect? Okay, okay, we collect the question from all of audience for 3 questions. Maybe in this offline room. From Zoom. Okay, Miss Rara, please. Okay, thank you, Miss Rara. There are 2 questions from audience. The first from Miss Bevina about how to determine metrics, right? And no. But okay, from Miss Bevina, and then from Miss Rara, how about distance when Miss Maira explain about matrix and distance? Okay. The last one, The last one question. Okay. Please. Mention your name and your institute, madam.
Okay, thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Fitrani Dwina. I'm from Universitas Negeri Padang. Bu Mira, you already explained it about 27 the type of DNA, but you just learned about 15. What is your reason that you choose 15, and how about the others? Thank you.
Okay, thank you, Ma'am Fitrani. So you asked to Bu Maira about the reason why you choose 15. Okay. You can answer now, Bu Maira. Okay, please.
Okay, thank you for Miss Devina Handari from Indonesia University, Universitas Indonesia. Okay, the membership function have four. I'm so sorry. Membership function for input variable consists of three variable, that is small, medium, and large. How can I determine it? The membership function for small is when the shift of the STR value more than 0.2. The shift of this STR between the victim, or we can say the query, and the record in a population of the tribe. And then the medium the value of the medium variable is 0.2 to 0.5 of the shift the STR. And the last one is the large variable. It's from 0.5 to the 1. We can say that when the similarity between the query and the population in the data set of the tribe have the similarity large when the shift of the STR less than 0.2. There is the explanation, Miss Devina.
Okay. Thank you. By the way, have you tried for another measurements different than you said previously?
Yes, I have some beberapa kali do the research and try it, but the best membership function I have when I use this one.
Okay. Okay. Thank you very much.
You're welcome, Ms. Bevina.
Okay. So this is answer your question, Ms. Bevina, right?
Yes. Thank you.
Next question, Miss Maira from Miss Rara about why.
The meaning of the
the meaning of the distance when you explain about matrix. Okay. This Bu Maira.
Yeah. Thank you, Miss Rara, for the question. It's a good question. The meaning of distance, the distance here is the distance between one feature. We have 15 loci in a data set, so we have 30 feature because one locus have the 2 allele, so we have the 30 feature in every record in dataset. The distance here is mean that the sum of the, what we call it, the difference one feature in the same LL in the same locus. So we have 30 the 30 distance for one record, and then we can average, we can get the average value. It means the distance of the one record in tribe. So for the tribe, we can average the of the all record or population in a tribe. Okay, is it clear? Okay, you're welcome, Ms. Rara.
Okay, so it's our answer, Ms. Rara question, right? Okay, the last question from Ma'am Vera about the reason why Bu Maira choose just 15 from 27. Okay, please, Bu Maira.
Okay, thank Miss Ma'am Vera for the question. I use the 15 locus in this research because amelogenin is the locus that determine the gender of someone. So the amelogenin, not the integer str value, okay, but it is the character str value. XX for female and XY for the male, and we the other there is a Y chromosome, or we can say YSTR chromosome, that only owned by male. Therefore, the victim of the disaster or terrorism attack can be male or female. So the female doesn't have the Y chromosome, so we not included in the research. Yes. Is it clear, ma'am?
Okay, thank you, Bu Mira. And how to select? Yeah, you said that female doesn't have the Y chromosome. Yeah, so you just focus for male chromosome.
No. If I include the Y chromosome, I focus to the male, only for male. But if I exclude it, the Y chromosome, I focus for male and female.
Okay, thank you, Bu Mira.
Thank you. You are welcome, ma'am.
Okay, all right. Thank you very much, Bu Maira. You have answered all of questions from audience. Thank you very much for your insightful contribution. Before we conclude this session, I would like to present you with a certificate of appreciation on behalf of the International Conference Mathematics and Mathematics Education Committee as a token of our gratitude. Please, committee certificate for Bu Maira. Oh yeah, for what? Okay, okay. Please, Master of Ceremony can handle it.
To honor the valuable contribution shared today, we will now proceed with the certificate presentation. Ladies and gentlemen, please join me in welcoming Dr. Suherman, our head of department, who will present the certificate to our esteemed speaker. Dr. Suherman, the stage is yours. Okay. We will present the certificate symbolically in the presentation, and we have Mr. Seherman and Ms. Mera Parmadewi to officially stand in the front of the stage to take a photo.
Okay. Okay. So before we end our session this afternoon, I wanna say about summary of Miss Bumaira's presentation today. So the conclusion of Bumaira's material is that mathematics is very broad, can be applied to various fields, computing, bioinformatics. In bioinformatics especially, it turns out that it can process data in the fields of biology and medicine. So it's so useful for society. And for our audience, we really appreciate your attendance and for being wonderful participation during this session. Thank you very much and see you next time. Thank you, Bumaira, and thank you for all of our audience.
Thank you, Dr. Mira Parmadewi, MCom, for your excellent presentation, and Mr. Wahyu, and the moderator for a lively discussion. Next, we are pleased to have Professor Dr. Matthias Ludwig, who will be joining us online. This session will be moderated by Ms. Sinta Sari, MED. Please welcome Professor Dr. Matthias Ludwig. Oke, kepada para partisipan kita istirahat dulu sekitar 15 menit. Nanti pukul 14.30 kita berkumpul kembali untuk sesi paralel berikutnya. Terima kasih. Di luar telah disediakan, di belakang sudah disediakan snack ya, dan juga kopi. Dipersilakan kepada para partisipan yang berada di dalam ruangan.
Selamat datang di Universitas Negeri Padang, tempat di mana masa depan cerah Anda dimulai. Kami dengan bangga mempersembahkan program studi baru yang dirancang untuk memenuhi kebutuhan industri modern. Program studi S1 Ilmu Aktuaria.
Ilmu aktuaria adalah disiplin ilmu yang menggabungkan matematika, statistik, dan teori keuangan untuk mengelola resiko di berbagai sektor, terutama asuransi dan keuangan. Peluang karir dalam bidang aktuaria sangat luas dan beragam. Menurut Otoritas Jasa Keuangan, Indonesia membutuhkan lebih dari 1.000 aktuaris bersertifikasi untuk memenuhi permintaan industri.
Program studi ilmu aktuaria di FMIPA UNP menawarkan kurikulum yang komprehensif dan dirancang untuk mengasah keterampilan analitis dan pemecahan masalah. Anda akan belajar dari dosen berpengalaman dan ahli di bidangnya. Fasilitas kami lengkap dan modern, yang mendukung proses belajar mengajar yang efektif. Kurikulum kami juga mencakup 3 peminatan utama, yang memungkinkan mahasiswa untuk menyesuaikan pendidikan mereka sesuai dengan minat dan tujuan karir mereka. Peminatan tersebut adalah 1. Pemodelan aktuaria. Peminatan ini fokus pada pengembangan dan penggunaan model matematis untuk menganalisis dan mengelola risiko dalam asuransi, keuangan, dan bidang terkait lainnya. Mahasiswa akan mempelajari teknik-teknik pemodelan lanjutan dan aplikasi praktisnya. 2. Sains data aktuaria. Dalam peminatan ini, mahasiswa akan mempelajari cara-cara mengolah dan menganalisis data besar untuk mengidentifikasi pola dan tren yang relevan dalam aktuaria. Fokusnya adalah pada penggunaan teknik sains data untuk mendukung pengambilan keputusan yang lebih baik.
Ketiga, bisnis dan keuangan. Peminatan ini menggabungkan ilmu aktuaria dengan pengetahuan bisnis dan keuangan. Mahasiswa akan mempelajari manajemen keuangan, penilaian aset, dan strategi bisnis untuk pengoptimalan keuntungan sambil mengelola resiko. Jika Anda menyukai matematika dan juga tertarik pada ekonomi, ilmu aktuaria adalah pilihan yang sempurna. Program studi ini menggabungkan keahlian dalam matematika dan statistik dengan menerapkan langsung dalam dunia keuangan dan ekonomi. Mahasiswa juga memiliki akses ke laboratorium komputer canggih, perpustakaan dengan koleksi buku yang lengkap, dan ruangan diskusi untuk mendukung kegiatan belajar.
Kami di FMIPA UNP berkomitmen untuk mencetak lulusan yang siap bersaing di dunia kerja global. Program ini juga memberikan jembatan kesempatan bagi mahasiswa untuk mendapatkan sertifikasi profesional yang diakui secara nasional dan internasional, membuka peluang kerja yang lebih luas. Lulusan ilmu aktuaria memiliki banyak pilihan karir, seperti aktuaris, analis risiko, underwriter asuransi, analis keuangan, konsultan aktuaria, manajer klaim asuransi, penasihat investasi, pengelola dana pensiun, dan aktuaris pemerintah.
Jangan lewatkan kesempatan ini untuk menjadi bagian dari program studi yang menjanjikan masa depan cerah. Pendaftaran untuk program studi S1 Ilmu Aktuaria dibuka dari 19 April hingga 10 Juli 2024. Untuk informasi lebih lanjut dan pendaftaran, kunjungi halaman web spmb.unp.ac.id/mandiri. Segera bergabung dengan komunitas kami di FMIPA UNP dan mulailah perjalanan Anda menuju karir yang gemilang. Universitas Negeri Padang mewujudkan masa depan cerah bersama program studi Ilmu Aktuaria. Tunggu apa lagi? Daftarkan diri Anda sekarang.
Selamat datang di Universitas Negeri Padang, tempat di mana masa depan cerah Anda dimulai. Kami dengan bangga mempersembahkan program studi baru yang dirancang untuk memenuhi kebutuhan industri modern. Program studi S1 Ilmu Aktuaria.
Ilmu aktuaria adalah disiplin ilmu yang menggabungkan matematika, statistik, dan teori keuangan untuk mengelola resiko di berbagai sektor, terutama asuransi dan keuangan. Peluang karir dalam bidang aktuaria sangat luas dan beragam. Menurut Otoritas Jasa Keuangan, Indonesia membutuhkan lebih dari 1.000 aktuaris bersertifikasi untuk memenuhi permintaan industri.
Program studi ilmu aktuaria di FMIPA UNP menawarkan kurikulum yang komprehensif dan dirancang untuk mengasah keterampilan analitis dan pemecahan masalah. Anda akan belajar dari dosen berpengalaman dan ahli di bidangnya. Fasilitas kami lengkap dan modern, yang mendukung proses belajar mengajar yang efektif. Kurikulum kami juga mencakup 3 peminatan utama, yang memungkinkan mahasiswa untuk menyesuaikan pendidikan mereka sesuai dengan minat dan tujuan karir mereka. Peminatan tersebut adalah 1. Pemodelan aktuaria. Peminatan ini fokus pada pengembangan dan penggunaan model matematis untuk menganalisis dan mengelola risiko dalam asuransi, keuangan, dan bidang terkait lainnya. Mahasiswa akan mempelajari teknik-teknik pemodelan lanjutan dan aplikasi praktisnya. 2. Sains data aktuaria. Dalam peminatan ini, mahasiswa akan mempelajari cara-cara mengolah dan menganalisis data besar untuk mengidentifikasi pola dan tren yang relevan dalam aktuaria. Fokusnya adalah pada penggunaan teknik sains data untuk mendukung pengambilan keputusan yang lebih baik.
3. bisnis dan keuangan. Peminatan ini menggabungkan ilmu aktuaria dengan pengetahuan bisnis dan keuangan. Mahasiswa akan mempelajari manajemen keuangan, penilaian aset dan strategi bisnis untuk pengoptimalan keuntungan sambil mengelola resiko. Jika Anda menyukai matematika dan juga tertarik pada ekonomi, ilmu aktuaria adalah pilihan yang sempurna. Program studi ini menggabungkan keahlian dalam matematika dan statistik dengan menerapkan langsung dalam dunia keuangan dan ekonomi. Mahasiswa juga memiliki akses ke laboratorium komputer canggih, perpustakaan dengan koleksi buku yang lengkap, dan ruangan diskusi untuk mendukung kegiatan belajar.
Kami di FMIPA UNP berkomitmen untuk mencetak lulusan yang siap bersaing di dunia kerja global. Program ini juga memberikan jembatan kesempatan bagi mahasiswa untuk mendapatkan sertifikasi profesional yang diakui secara nasional dan internasional, membuka peluang kerja yang lebih luas. Lulusan ilmu aktuaria memiliki banyak pilihan karir, seperti aktuaris, analis risiko, underwriter asuransi, analis keuangan, konsultan aktuaria, manajer klaim asuransi, penasihat investasi, pengelola dana pensiun, dan aktuaris pemerintah.
Jangan lewatkan kesempatan ini untuk menjadi bagian dari program studi yang menjanjikan masa depan cerah. Pendaftaran untuk program studi S1 Ilmu Aktuaria dibuka dari 19 April hingga 10 Juli 2024. Untuk informasi lebih lanjut dan pendaftaran, kunjungi halaman web spmb.unp.ac.id/mandiri. Segera bergabung dengan komunitas kami di FMIPA UNP dan mulailah perjalanan Anda menuju karir yang gemilang. Universitas Negeri Padang mewujudkan masa depan cerah bersama program studi Ilmu Aktuaria. Tunggu apa lagi? Daftarkan diri Anda sekarang.
Okay. Good morning, Mr. Matthias Ludwig.
Morning. Nice to see you.
Nice to see you too. How are you today?
Yes, it's fine. The sun rise up 2 hours ago, but now it's a little bit cold in Germany. Not so hot as in Indonesia, I think. Yes, so, but it's okay.
Nearly 40 degrees here.
Really? Okay, so we have now 9 degrees, so it's really cold. So 40 degrees, unbelievable. Okay, yeah, good. So should I start, or how do you want to do that now?
Okay, so I will be the moderator for this session. So I will open the session first, and then after that you can deliver your presentation.
Okay, great.
Okay, so we have done with a coffee break in this room.
Ah, okay, yeah. Now it's coffee break. You're right. So nobody is here. I understand. So okay, and Padang is in the west part of Sumatra. That's right.
Yes, that's right. Yeah, it's West Sumatra.
Okay. So, and you understand me very clear. Everything is okay, and
yeah, everything is good.
Good. Perfect.
All right, so let me start it. Bismillahirrahmanirrahim. Good afternoon, everyone. Already afternoon in Indonesia. So once again, welcome to the 7th International Conference on Mathematics and Mathematics Education 2024. My name is Sinta Sari, and I am honored to be your moderator for this 4th keynote session today. We are thrilled to have participants from diverse universities and expertise join us to share insights and advancements in this conference. But before we begin, I would like to acknowledge our esteemed guests, speakers, and all attendees for taking the time to participate in this conference. We truly appreciate your commitment to advancing knowledge in mathematics and mathematics educations. Now, I'm delighted to introduce our speaker, Professor Matthias Ludwig. I hope that I pronounce your name correctly.
Perfect. Very good.
Okay, and I will deliver a brief CV of Professor Matthias Ludwig. Professor Matthias Ludwig is a professor at Goethe University Frankfurt, Faculty of Mathematics and Computer Science, Institute of Mathematics Education, Germany. So Professor Matthias Ludwig holds a master's degree as a teacher for mathematics and physics for lower and upper secondary school in 1994. He has taught in school for more than 8 years. His research interests includes mathematics education in China, project-based learning, space geometry, mobile learning, new technologies, and modeling and applications. Professor Matthias Ludwig has several experiences related to mathematics education. He was founder of a bilateral cooperation between PH Weingarten and Zhejiang International Study University. He was also guest speaker at Monash University, Australia in 2012, and British University, South Africa in 2017 and 2019, and also being a visiting professor at Aldo Moro University, Italy. And yeah, there are so many other awards and achievements of Professor Matthias Ludwig that you can read on his CV. So today, Professor Matthias Ludwig will sharing insights on teaching beyond COVID-19, the possibilities when teaching with applications. It's including math trials and math city map. So please join me in welcoming Professor Matthias Ludwig to the screen. And Professor Matthias Ludwig, please feel free to take your time.
Okay, thank you very much for this very nice introduction. So I share my screen, that's fine, okay? That you can see my presentation. So, okay, now you should see my screen. Yeah, I see that you see my screen. Perfect. Okay, so now let's go. Yeah, I want to talk about teaching mathematics with apps and why I call it teaching beyond COVID-19. The beginning was when we start with math trails and math city map. Perhaps first the definition, what is a math trail? So a math trail is a walk outside the school, and at some positions you find objects, and on these objects there are mathematical tasks. Okay, so you can discover mathematics. A math trail can be everywhere. Yes, we have math trails in every part of this world, on every continent, and also especially a very lot of math trails in Indonesia, created by Adi Nur Kayono. He was my PhD student, and I'm very proud of him. And you need a math trail guide, a map where there are points, so you can find the spots where you formulate, discuss, or solve interesting mathematical problems. And you can walk the math trail alone, or with a family, or with another group. And when you are in a group, you cooperate along the trail because you discuss the task, the problem, how to solve it. And so you talk a lot about mathematics. And that's a very important thing. So this is one example. You see a ramp for wheelchair, and this is now obvious for every public institution, they have to build such ramps. And the question here is, what is the slope of a ramp? Okay, of this ramp. And in mathematics classes about grade 8, when they are 13, 14 years old, there will be teach the concept of slope, but only in their textbook. So they don't have an idea what means 10% slope, or how does it feel when you walk up 10% or 20% or 30%? Yes. So, and in the textbook, a slope looks very, very yes, narrow, not steep. Yes, but when you are outside, it's completely different. So here, one task could be, please calculate the slope of this ramp. Gives the result back in degrees or in percentage. Yeah, that's it. You can differ. The math trail idea is coming from Australia and US. There are, by example, there are some math trails about the Niagara Falls, or in Melbourne there was a trail around the city. But we also find math trails in Singapore. Yeah, so Berinda Kaur, she also started math trails there in the last century. Yeah, so it's very old method to teach mathematics, but the problem was it was very isolated. Yeah, so for a normal teacher, it was not possible to find the ideas. Yes, it's only when they are very interested in international conferences, then they can grab an idea from that. But for a normal teacher, it was not possible. I want to change this. Yeah, so I want that this very good and very fantastic mathematics teaching idea reach to a lot of persons. And that was the reason I started 3 different European projects. One in 2017, the next one in 2019, and the last year Matrix. Yeah, so, and I take a lot of partners from Europe, and we work on an app. We work on special tasks, yes, to promote math trails in Europe or in the world. So we want to make this analog idea, which is very great, goes digital. So here you see one result. This is the web portal you see here. Yes, you see on the right, you see a map of Frankfurt, for example. And you see pins, and each pin stands for a task where you can walk, okay? And the red lines between the blue pins, these are the way you have to walk, for example, okay? MathCityMap uses the advantages of out-school learning. This means when you're outside of the school, you are motivated, much more motivated than in the school. There's a lot of variety, yes, and of course you have the possibility that your memory, yes, takes more of this learning than when you're in the class. Here you see some girls who do math trails in Stuttgart, in a big city in Germany. Yes, we use the authenticity of real objects. It's so hard to create a real authentic task for mathematics education in classes. But when you're outside, there's no problem because the objects are there. They are real objects, so they're authentic. Yes, so this is very great. Yes, here, by example, you see a figure, a big object, only a head of a person, and the question is, what will be the height of the person when it's completely and not only the head? And so then you have to think about your own body. Yes, you have to think about the proportion between head and your height of a body, and so on. Yeah, so you need the proportion idea. Then the next thing is you want to make that MathCityMap is a community project. Okay, community project means that we can exchange tasks. Yes, that we can exchange ideas. Yes, that I can go to another city and solve this task there, and I know where the tasks are because I'm connected with every public trail. Here you see teachers creating tasks on the app. You have to know that in these last years, we have a lot of users in our system, because perhaps I can come to this later. So my city map is a two-fold system. This means I have a web portal and an app, okay? And this idea of a system for applications in school, I do with every app I develop here in my institute. Okay, so let's start first with a web portal. How does it look like? When you go in the web portal, you can click on public task. Every task is like a blue pin. When there are green dots, this means that are much more tasks very narrow together. You can read on the left side, for example, the name of the task. Okay, now these are German tasks, of course, because these tasks are in Germany. It makes no sense to have a German task in Indonesia. Yeah. So you can have also a three-dimensional view if you like. And now you see I zoom more in, so the pins are distributed over the whole university. So now I can click on a pin. You see here now a light blue one, okay? And when I click on this light blue one again, then I see here the name of the task, and it shows me now the description of the task. Yes. So and when I like this task, I can say, okay, this is a nice task. I want to keep it in my line for next training for my students. Okay, and now we go to the app. How does this app works? The basis idea of the app is a navigation. Yes, here's a map. The blue point, this is you know this from Google. Here in this direction, this is your view. The blue pins are tasks you didn't solve. The green pin is you solve it very good. Yellow means you make it okay, but not perfect. Gray means you skip it. And red means, okay, you didn't solve it and you give up. Okay, but that's not very often. Then the app also is here to provide the task. Yes, so you cannot find normal single tasks. You only find trails, and in these trails, the app provide you the task. Okay, you can get hints. Each bulb here is a hint. Okay, how do you determine the volume of a truncated cone? It's here because here it's asked what is the volume of this object. Okay, and the last one is adapted feedback. Okay, you're right, you get 100 points. Your answer 80 is right. Okay, so we have 4 basic features of the app. Okay, the problem is that the teachers, they don't really want that the students go alone there, okay? And there's no physical control, no direct feedback from the teacher, for example. That's the reason we develop the digital classroom in the Maske project, okay? The app we developed in the Momata project, now we develop the digital classroom in the Maske project. And this means we have 4 elements. We have a task monitor, we have a chat, we have an event monitor, and we have the geolocation. So this shows you the view of the teacher. These are the teams, Dream Team, Mathematician, Siegfried, Dream Team again. So, and you see they have a lot of green bullets. This means they solve the task in a very good way. Okay? And here I see these are not so good, and Siegfried only have one task solved. And so he's alone, sorry, and perhaps he needs some help. Here you see this is a trail, and now I click on Dream Team, yes, and I see how the team goes on the trail, okay? They follow the trail, and you see here this takes very long, and this position to solve the tasks. Yes, here it was faster, and so on. So it's very good that I know where the students are. It's very good that I can chat with them. It's very good that I can send pictures to them. They can send pictures to me, yes, to ask me something. But then in March 2020, 4 years ago, the Corona crisis was coming, and we create Mass City Map at Home. Why? Yes, so in 2020, there were no mass trails possible. No measurements are possible. Yes, we changed the requirements for an MCM task. This means now it is not necessary to go to the position where the pins are. All the informations you get directly from the task. Here, by example, there's a map, and they have to estimate the length of the horse racetrack, gives the result back in meters. Normally, when there's no Corona, you can go there and can measure the length of the horse track. So there you see some measurements, and you can do it here. So we call it Mass City Map at Home. They are real objects. We take pictures from real objects, but we put it not on this position where it is, because it's not necessary. But yes, we can provide the task via smartphone. Okay, so what was the motivation for the Corona crisis here to do something? It was how to deal with emergency remote teaching. So from one day to another, the teachers have to deal with the situation. It was really horrible for them. Yes, perhaps they have not the technology equipment. They have not the technology education in that case. Yeah, there was a big lack of technical knowledge on the teacher side. Yes, because it wasn't necessary before. And then when we look on some platforms, you only found reproduction tasks and no conceptual tasks, for example. Yeah, and the other problem was that only a few students have laptops. Yes, a lot of learning platform only works with laptops. But in a family, there's perhaps one laptop, but when there are 3 children, what you're doing, so they cannot work with this in the classes. Okay, but nearly all have smartphones, and that was our idea. We go there because there are a lot of smartphones, so we go there and we want to create a new app. Yes, so we want to have the diagnostic and support for the students. We know there is no personal contact, and there were only reproduction tasks. And this was the idea of the Asymptote project. Asymptote means, again, that we have a lot of European partners from Portugal, from Spain, from Germany, yes, and also from Italy and Greece. Yeah, and the idea is that we create an app which provides good tasks, good mathematical tasks, open tasks, mathematical tasks. Here you see the partners. Yes, so it was again a European project from Erasmus+. You know? And the name, why we called it Asymptote, because it was an adaptive synchronous mathematics learning path for online teaching in Europe. It was a so-called strategic partnership, and again, a 2-component system. We have an app, we have a web portal, like MCM, to create an adaptive learning graph. Yes, in the web portal, you can drag and drop tasks to create a learning graph to the teacher, and the app intuitive, gamified working with learning graphs. Yes, working with learning graphs in classes, we can use the digital classroom, you know, because then I can really help them. It's really great. So we can use the development we developed 1 year before, and we can have a manifold evaluation of the learning graph work from one or more students. Okay, this is the learning graph concept. Okay, we have the main task. This is every student is compulsory for every student. Okay, when they didn't solve, or when they have no idea how to solve this main task, then they can get help by a support task. Okay, or when they are really good, they can have a challenge task and the next challenge task. And when they solve it, they can go back to the next main task. So yes, that's what I said. I said that these are the main tasks. Yes, the students start with the first main task, solve as many main tasks as possible. These are the voluntary, the challenge task, and here are the support tasks. They can be consulted. Okay, it's not necessary, but they can be consulted. Yes, and the students, here's, for example, a way one student goes through, starts here, solve it. Yes, have the first challenge task. Go there, want to solve it, go back and go to the main task tree. Need some help from the support task, go here, and also here, but didn't solve this task. This is the idea of asymptote. The idea again is that the teacher can create and provide own task. Yes, like on MyCityMap. So we build a community. Yes, and every day some people in the world create asymptote task and put it in the system. Here you see the learning graph on the web portal. Here you see the where you can choose task and put it over here. That's a great thing created by Ken Oehler. Here you see how you have to type in the solution and so on. You can use, of course, LaTeX to do this. And yeah, here we have fractions. You can use fractions. And again, you can have hints as you know this. Yes, from MyCityMap. So it's the same idea, but you can use it for different contexts. And I will show you a third app we develop in my institution. It's called Colette. Colette stands for computational thinking, okay, and learning. Again, we do a Erasmus Plus partnership with partners from Slovakia, from Austria, from Netherlands, from Germany, and from France here again. And I mean, computational thinking is made up of many subcompetencies and processes, such as the ability to break down complex issues into problems that are easy to solve, or to recognize similar patterns for certain areas of application. Use them to analyze things, yes, as we do here with our twofold app systems, yes. Distinguishing the essential from the non-essential, working through steps to a solution, e.g. an algorithm could be somewhere, and then evaluating an algorithm, e.g. in terms of the time required, the results, etc., etc. So this is computational thinking, yes. And here again, we create an app and a portal where teachers can create tasks and students, they can solve the task, yes. Here is the app, it's a my passes, my task, public task, and how now you can learn more about computational thinking. This is how it looks like. Sorry, go back. Here is a first pass, for example, so you can do some three-dimensional things. And yes, you can, here, this is how it looks like in the app. in the web portal. You can create own tasks. You have to not to use a pre-designed task. You can really use your own task. That's the main idea of this, okay? And here is like the app looks like. You have here computational thinking passes. Then you start it, okay? And you can do some coding, by example. And then you can use your phone, and we have AR here in the augmented reality design inside here. Okay, so you can really choose it in a very, very, very cool way. The students, they love it a lot. So I presented to you today my city map, Asymptote, and Colette. And we create also a trail, an archeo trail for archaeologists. Okay, and they all use the same idea, a web portal where teachers can create tasks. So they can really create tasks, especially for their students. And then you can provide this task via a smartphone. Yes, that's cool, because then you can send them where they are, everywhere, at home, or they can also work with a smartphone in school, okay? So it means it's not necessary always to have a laptop, perhaps for when you have to do some research to solve and to get data, for example. And our latest project is called Dimension. Here you see the logo of Dimension. It's again an Erasmus Plus project, okay, with several partners from Sweden and Spain, Portugal, by some in Germany. And here we go on the asymptote idea to provide students modeling tasks, which are, the content is about the SDGs, the sustainability development goal of the United Nations. Yeah, so we create a task, and not only we, but also our partners, we create the app, we create the web portal, and then in 1 year, it's ready to use. And perhaps you are interested to be part of this project. Yes, it's possible. Yes, when you say, yes, I really want to create modeling tasks which take care about the SDGs, this is possible. So thank you very much now for your attention. I hope you enjoyed my lecture and now have a lot of fun during the ICM2E. And when you have questions, please do not hesitate and pose it to me. Thank you very much.
Okay, thank you, Prof. Matthias Ludwig, for your enlightening presentation, and we appreciate the valuable insight you share. Now it's time for us to open the floor for the questions. So for the participants who attend this room, you can raise your hand to ask questions, and for participants who join us online, you can click raise hand button, or you can text it in the chat box. Okay, thank you. Now we have one participant's question. Yes, you can use microphone. Please kindly mention your name and your institution and your questions. Thank you.
Okay, thank you, Sinta. My name is Yulian Harisman. I am the lecturer in mathematics education study programs. Thank you, Mr. Matthias Ludwig, for the nice presentations. I think I interest with this topic. This is about MCM or math city maps. I think I have 3 questions about that. The
okay,
first,
go on.
Sorry. Okay, the first one, how we get the apps. This is the free apps, or we must pay something to get it. And the second one, what is the function of the trials or the place for each trials? It just to take assignment for the student, or this is have the others function? I think I want to you explanation it. Okay. The third one, I think if the other researcher have the trial, can we get or we can't do that or use that to our research, or we must make the new trial and new place to do our research? Thank you very much. Thank you, Sinta. I give back to the moderator.
Okay, so the first question is about how much does it cost? Yes, so it's financed by the European Union, okay, the web portal. And this means why it's you can use it free. Yeah, you can download the app free. Yes, that's really easy in that case. And the next was how you can use the trail or how you can get the trail. Was it that, or I didn't really get the second question?
Yeah, the second question is what's the function of trials?
Okay, yeah. So the function of trial is that you go outside, and when you're outside, it's better for you to learn. Yes, so it's better for you to learn, and because you have more senses. Yes, you have the sense of smell something. You can touch something. Okay, and you learn outside your environment. You know your environment. You feel perhaps more safe, and so you can connect mathematical concepts with a real object, and then you remember it better. Okay, so I know that in Indonesia it's very hot, so you perhaps it's not so common to do mathematics outside because it's so hot. In Germany, we can do it very easily from March until November because in this time it's okay. So in winter it's too cold, we cannot go out. So doing math trails is for the students very motivating. Adi Nur Kayuni shows that the students have much more motivation and that they are better in mathematics after they do some math trails. Okay, and so that's the reason we do some research in math trail. And the third question was how do you can get the task? So because the system is free, and we have the system is also in Bahasa language. Yes, so it's translated by Adi Nur Kayono, so you can use it. Yes, so you can find. Perhaps I share my screen again, and here Bahasa. Then I can show you. Okay. Okay, let's go back. So here see, this is our this is a web portal, and perhaps I can here type in Semarang. Okay, Semarang. Yes, it's here in Indonesia, and I'm sure we will find trails there. Okay. define public, of course. I think there should be a lot of public trails in Semarang. Yes, here. You see more than 100, and you can go deeper and deeper. And of course, you can use this. Yes, it's free. You can use all these tasks. You can go there. You can click on a task. Take this one here. Oh, this is always cool. This one here. Vertical gardens. I don't know exactly what this is, a task, but it's free, so it's yeah. So this, you can use this task. You can copy it and can use it for you. But of course, you have to do a new picture. That's also clear. Yes, you have to do a new picture. Okay. So is this perhaps answering your question?
Okay, thank you, Mr. Matthias Ludwig, but I want to extend my question. If I catch your explanation about that, so the task is must related with the place of the trial, or we can't
Yes.
do the task, random task, or
No. It makes sense. For example, when somebody knows, for example, is this area, so this building here, this school, yes, this is here, okay, it's exactly there in this position, and that's the idea. Yes, you go there, and I can show for some trials here in this area. There should be also some trails.
Okay, thank you, Professor.
Yes, you're welcome. Other questions?
Okay, that's fine, Professor Matthias Lewitt, if you want to explain more about this Math City map, because it is so interesting, I think, yeah, the application when the students can also learn about maps and can learn about geography, and then they can learn about math in the same time.
Yeah, that's it. Okay, so when you have a smartphone here now, for example, in the conference, and you download the app, yes, so the app is completely free because it's financed by the European Union. Okay, so I will not charge anybody for use this app. Okay, and when you have the app download, then you can ask the okay. Then you can ask to add a new trail on this app. Yes, that's here. For example, you have to ask new trail, and then you type in a code. Yes, you type in a code, and when you type in this code, the app downloads the trail on your phone, and then you can click from one task. But to solve the task, you have to be directly near the object. Yes, that's the most important thing. You have to be here at the object. Yeah, so because you have to take some data, or you have to count something. Yes, or you have to look around the corner. Yeah, or you have to do some measurements. Yes, for example, you ask, what is the age of a tree, of this tree? Okay, and there are some rules how trees are growing. Yes, especially the trunk. There's sometimes in some years the growth is very proportional to the time. So this means every year 1 or 2 millimeters of the diameter, and from this you can estimate the age of the tree. But for that you have to estimate or calculate the diameter, and for that you have to measure the circumference. And so always use mathematical concepts to solve at the end the task.
Okay, cool. But yeah, maybe it's impossible for the students to choose the task, for example, in Frankfurt,
Of
somewhere
course,
in
of course.
Frankfurt, while they are in Indonesia?
They can go on this task, is it's not problem, but of course they can also get ideas. So, by example, when I yes, let me go back to this task here, to this public task, and here, by example, when we go on this task here, trail. I know I want to trail. I want tugas. Tugas is task. Okay. So I learned some Indonesian now. So okay. So the system loads the task now in the near of okay, and you have to synchronize it with the area with the map here, and public task, and then I will find public task. So a little bit. Okay. So I click here or here. So when you click on the task here, okay, then you see some tags. This is about volume, okay. Balok, column, I don't know the English these words, but you know that, okay. Column, I think means yes, so. And here Adi did this, you see. And now I can really look on this task, okay. I can look on this task. Yes, I can look on the sample solution. Yes, and this is a test task, I think. Okay, so I go back to the, and you can really get information, and you can get ideas. But it makes, as you said, it makes no sense to use these tasks exactly for. So perhaps this is a little bit better. So you see is another person. Here is a sample solution of the task, okay? And I say, okay, I have a similar the same objects in my school, so I can use a task idea. That's the important point, yeah? They can use a task idea of that, okay?
Okay, so yeah, that's very cool applications, Prof. Mr. Lutfi. And yeah, we have another question.
Okay.
Yeah, I will read it for you. Hello, my name is Nina Agustianingrum. I am lecturer from Universitas Tidar, Magelang. Yeah, it's in Magelang, near from Semarang, maybe. I want to ask some questions to Prof. Lutfi. Please let me write my question here. So this is the question. How can we monitor students' activities outside of school through the Math City Map project? How can we ensure that all students will participate in completing the project?
Okay.
If students encounter difficulties, such as consistently inaccurate measurements, what steps should be taken to address these issues? And the last one, should teachers directly accompany students outside, or is it unnecessary?
Okay, so I think I start with the last questions. It depends on your country. Yes, so about the rules. In Germany, is it when three students are together? Yes, they can go out. Yes, but not only two. There have to be three. So that's the reason we send students out in three groups, as in the group of three. Yeah, so that's the first one. Then, yes, if you don't trust your students, and you are right when you don't trust them every time, you can use the digital classroom. The digital classroom means that I monitor the students with their phone. Yes, I know where the phone is. Yes, I can see it. I know what they type in. I know which task they solve at this moment. And when they have a problem, yes, the students can ask me via a chat, where are the problems? Okay, so I really can see what they are doing outside. Okay, and that's the main idea of the digital classroom. Did you get it, or did I explain it in a good way, or?
Yeah, okay. That's very clear answer from you.
Good. I mean, you talk about incorrect measurements. I mean, the first thing, when the result is wrong, they get a feedback from the app. That's the first thing, okay? And then they try again, it doesn't work. And then they can ask me. Then, as I sent me a picture, for example, what are your measurement data? And then they said, oh, I measure this tree has a circumference from 1 meter and 20. I said, no, you're wrong. It's 3 meter and 20. Yes. So, because I can really chat with the students. That's important.
So the teacher can give feedback directly to the students?
Yes, directly. Yes, directly. That's possible. In the digital classroom, it's possible.
That's cool. Okay, yeah, I hope that Miss Nina, the explanation, yeah, she got your answer, sir. Okay.
Okay, thank you.
Yeah, next question from the other participants. Hello, my name is Reviona from Universitas Negeri Padang. My questions are, first, is the use of apps and portals applicable for primary school students? And second, is my understanding correct that the app can be used when students already understand the math concepts? So the app is a tool to train their understanding of the math concept.
Yeah, thank you very much, Reviona, for these two questions. So, yes, the app is also used by primary students, yes, from primary school. Perhaps not in the first 2 years when they cannot read, but when they start reading, they can read the task. And I mean, you know that using apps is easy for young children, yes, because we code it in that way that the use of the app is really easy for them. And the task, if they are applicable for the students, that's in the responsibility of the task creator. Yes, I mean, it's of course it's not good when you give them questions or tasks which are for sixth graders and not for third graders. But of course you can create tasks like that. A very easy one is how many windows are on a big building. Yes, so they have to count and to multiply and so on. So they start, and that's the second question. They can connect mathematical concepts with the real world. So this is modeling. Yes. So you teach the concept in classroom, and then they apply the concept in the real world, and this makes learning very, very fruitful. Yes. So and of course you can also create math trails to learn some mathematics. Yes, but this is not the normal case. The normal case is you teach them the concept in classroom, and then you go out to apply and to train the mathematical concept. That's it.
Okay, thank you, Prof. Matthias Ludwig, for your explanation. Maybe do you have any other questions for the participants? You can type your questions in chat box in the Zoom application, or maybe in home you can raise your hand.
It's a very good idea with the chat.
Yeah. Okay, any other questions? Please raise your hand. Yeah, I have tried to download the applications, the Math City Map. Yeah.
Does it work?
It's free of course. Yeah, and yeah.
Then normally, I mean, a remote task about MCM is always not so as yes nice. Normally, I have to come to you to Indonesia to create tasks there, and then we all go out and test these tasks, and then you create your own task. Yeah, so that's the normal way. I did it very often in Poland last week, in Portugal, and so on. And but I understand that it's Indonesia is a very, very huge country, and you have so much islands, and it's so it's a Zoom conference is a really good thing in that way. Yes. But normally you have to try it really by yourself to get the feeling. Yes, it's sometimes not so good to imagine what this is doing with you when you're outside and do measurements. Do you really start discussing about yes, mathematical formulas. What you have to measure for this formula? Is this length or this height or this diameter? So you really start to understand as this mathematical concept in a other way. Yes, in a way which is not opposite, but it's more embodiment. Yes, you learn with your body, and in school you have a lot of cognitive things, so you use when you're outside your body, and that's very important.
Great. So how many cities in Indonesia that you have created the Math City map?
Sorry, I don't get the beginning of your question.
How many cities in Indonesia that have?
I visited Semarang, of course, and Yogyakarta only. So these two cities I visited. And I visit Jakarta airport, so but not really Jakarta. So.
Let's go.
Yes, I have been in Denpasar too. Denpasar, yes, yeah, yes, that's my. So it's perhaps the next time I can visit you in Sumatra.
Thank you. Yep. Okay, so we have another question from participants in the chat box. Hello, my name is Fadila Ramawati from Tidar University. Mr. Ludwig, I teach this specifically in one course, but so far I direct students to make tasks that can be measured with measuring tools. Can you explain to us how to estimate a fairly large area? I forgot which slide the example was on. Okay.
Okay. You mean the area where the task is, where the trail is? Is this what you mean? So I mean, I can say normally a trail should be not longer than 1.5 hours, by example. Yes, because this fits in 2 54-minute slots. But you can make it smaller or bigger, and you should not walk so much between two tasks because this is time you do no mathematics. Okay, so but it depends when you have the whole day time with your students, then there could be much more tasks, there could be much more distance between the tasks and so on. So there's not really, when you really want to use it in school, the task has to be narrow, not too far away, maximum 100 or 200 meters between each task. And then it's also for you as a teacher very good because then you can see all the students. Yeah, so, but that's not really necessary. Yeah, so because you can use a digital classroom and you know exactly where they are with their smartphones. Okay, when they cannot go to McDonald's and drink a coffee, and because you see that, yes, you see that they are not on the trail, they are outside of the trail, and then you can text them, and then they will go back and solve the task.
Okay, thank you, Mr. Ludwig. I hope that answer your questions, Ms. Fadila. Okay, so any other questions? We still have 7 minutes more. Okay, everything is clear. Mr. Ludwig, I thank you for your presentation, and to everyone who participated in this question and answer session. Also, thank you for your questions. And Mr. Ludwig, thank you for your thoughtful responses to the questions.
No problem. I really enjoyed it. And perhaps I see you in 1 or 2 years in Padang. That's will be great. Okay. So bye-bye. And I only know Selamat Datang. Yes, it's what I don't know, but with everything. And but this means not goodbye. This means hello. I know. And yeah, really nice to be with you. And have a nice Saturday evening. Yes. So and I know and enjoy the very good Indonesian food. Okay, that's I
Thank you.
really.
But before you close your Zoom meeting, I want to share a certificate for you from the committee. So
Okay,
this is
great.
for your
Thank you very
presentation.
much.
Yeah.
Thank you very much.
Yeah, the committee will send this certificate online for you to your email shortly.
Yes,
So
thank you. Thank you.
thank you so much. Thank you so much. Have a good day.
Yeah, thank you. You too. Bye-bye.
Thank you. So, dear all participants, this is the end of the 4th session of the keynote speakers today. And I thanks again Professor Matthias Ludwig for his excellent explanation and excellent presentation for all of us today. So let me close this 4th keynote speaker session, and I will give the floor back to the MC. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi.
Thank you, Professor Dr. Matthias Ludwig and Ms. Sinta, for that engaging presentation, and all participants for the fruitful discussion. Ladies and gentlemen, as we conclude today's plenary session, we extend our heartfelt gratitude to all our esteemed speakers for their valuable contributions, and to all participants for their active engagement. We hope the insights shared today will spark further research and innovation in mathematics and mathematics education, aligned with our conference theme. We would also like to thank our moderators for getting each session smoothly. Before we closing, please remember that tomorrow's session will begin at 8:30 in Western Indonesian time, both for online and offline parallel session. We invite everyone to join and continue the discussion. Thank you once again for your participation. Have a pleasant evening and see you tomorrow. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
infokan lagi bahwa besok kita akan memulai sesi paralel ya. Per kelasnya nanti jam 8.30 di gedung FMIPA yang gedung barunya, gedung baru FMIPA lantai 2. Jadi kami beritahukan lagi bahwa besok paralel kelasnya dimulai jam 8.30 di gedung baru FMIPA UMP. Kemudian ada info. Demikian mungkin untuk informasi lebih lanjut nanti bisa selalu dicek ya Bapak Ibu pada grup presenternya, nanti akan ada penyampaian informasi-informasi penting. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.